All right, well, it looks like the number of people tuned in is plateauing, so I'll get started. My name's Leif Hauge. I'm the Senior Civil Engineer for Waukesha County's Department of Parks and Land Use, and I'll be serving as the moderator for today's workshop. This is, I believe, our 26th annual Stormwater Workshop. I'd like to thank Kelly Myers and Wisconsin Land and Water for facilitating this and taking care of all the technical aspects of the putting on the workshop. Um, this year, we have quite a variety of themes. We have speakers that are going to talk about MS4 compliance strategies, utilities, or utility districts, I should say, adaptive management, TMDLs, DOT permitting, extreme weather events, bank stabilization, stream bank stabilization, green infrastructure, pond dredging. We'll talk some about county online resources that are available, water quality trading, regulatory updates, and some other topics. Our schedule is to do this on 2 days, today and tomorrow, both days from 8 o'clock to roughly 11:30. We'll we do not have any scheduled breaks, but I'm going to look for an opportunity at about 9 or 9:30 this morning to try and fit in a 5-minute break so that people can get up and walk around a little bit. The format's generally half-hour presentations. Um, Tomorrow we do have a couple of short polls, but none are scheduled today. We do post the presentations as PDFs on our website. There's already at least 8 that are posted there currently. So if you want to somehow use them to do digital note-taking, they are available. To find them, what you need to do is Google Waukesha County Stormwater Workshops, and it should take you right to that page um, with the presentations that are posted. We do offer professional development hour certificates. To get them, what you need to do is complete the evaluation survey that will be sent in an email shortly after the workshop is over, and then you'll get an email certificate. We've had some issues with our mailings, both for the registration process and other topics going to people's spam folders. So if you haven't seen anything in a few days, please look in your spam folder first before reaching out. I'm going to give a little background on each presenter. If you have questions, please submit them using the chat at the bottom of the screen. And at the end of each presentation, I will ask them to the presenter. I'm going to generally turn off my video during the talk and then back on with about 3 minutes left in each presenter's presentation as an indicator that time is winding down. So our first presenter is Pete Wood, who's a water resources engineer with the Wisconsin Department of Natural Resources. He's worked for the DNR since 1991, has been with the Stormwater program since 1998. Currently, Pete reviews erosion control and stormwater management plans for projects in southeast Wisconsin. And Pete is basically going to give us a regulatory update on where things are at and what the new developments are. So, Pete, I'm going to turn it over to you.
Thank you, Leif.
Okay.
Figure out so that sharing issue, right? Oh, I think I got it. Maybe. Let's try that. Right. Let's try that. Can you see my screen, Leif?
Right now I just see a green box that says your screen sharing.
Oh boy. All right. Hang on a second. I've done this a million times, right? You would think I should be able to handle this.
We'll work it out.
Yes. Hang on a second. All right. So let's do this. There we go. Hang on. I think I'm getting it. Hang on a second. Got a lot of other stuff up. Let's do this. All right. So now, there we go. I think I got it, Leif.
Bada bing.
Nice. That was fun. All right. So now for the real fun, right? This is our annual DNR Stormwater Program updates. Just want to let you guys know that, DNR has actually we actually did some stuff this year. A lot of times I do these updates and I'm talking about things we're working on. We completed some stuff. So here we go, right? So let's get right into it. So what I'm going to talk about today is what we've been working on and completing for tech standards, guidance documents, a few like MS4 related updates, and then my favorite topic, the other stuff, right? So let's progress and start talking about tech standards. So what I'm going to talk, I'm not going to talk in detail about all these, but I just want to give you kind of where we're at. I am going to talk about the urban soil health tech standard that it is currently under development. So I'll give you some updates on that. The two things that we've completed, hopefully you've noticed, is the sand filter tech standard is available. The dry pond tech standard is available. Talked to Amy Mincer recently. She's getting really close to completing the enhanced phosphorus tech standards. Those are the basically alum treatment options for ponds. One is the actual continuous dosing. The other one is the one-time dosing. And a couple things I just want to mention that are like coming in the near future. Amy's going to start up a project to actually take our soil loss and sediment discharge calculation guidance document. That's the USLE spreadsheet concept that we've been doing for several years. She's going to repackage that as a tech standard and probably use a different concept from what we've learned over these years using the soil loss spreadsheet. So that's going to take some time to get through, but that's something that I think she's going to start up relatively soon. Another one that we've been getting a lot of at least questions about is the whole family of underground detention systems. A lot of these are those products. There's many on the market these days. And we need to get on this one at some point in time to kind of like level the playing field and treat them all the same way. But I just want to let you know that's one that's on our radar screen for trying to get done. But again, both of those are probably as far as completion goes, maybe a couple years off. So for future updates on those, but I just want to mention that they're on the radar screen and coming. So let's dive into the urban soil health tech standard. I know myself and Stu Schwartz and some others have been making the rounds talking about this topic for years, but just to give you a little background, we had pulled together a little focus group in cooperation with Milwaukee MMSD just to talk about the concept that urban soils, they're pretty damaged by historic development, filling, compacting, and that the idea that these are soils that are impacted. Can they be restored to kind of their best, to manage water better, right? So we pulled this group together, and I'm just listing over here on the right hand side, some of the ideas we talked about in that group, from basically a complete restoration of the soil profile to different aeration techniques to top dressing to different vegetation techniques. So that was the start. We had a really good start to a tech standard. So as of November, we actually pulled the tech standard team together and we're working on it right now. So I'm just going to give you some updates of where we've been heading. Here's some more background too. The tech standard is going to be interesting because it's going to be kind of like a multi-use tech standard. We can envision it being used by municipalities possibly for TMDL compliance, basically restoring existing pervious areas to their best self. And this is an example of that. Now, this is a project in West Dallas where the city was planning on basically removing this dead end. So basically removing pavement and then putting it back together again in a way that is thoughtful to water management. And that's exactly what was done in this dead end. It was used as a research facility. Stu Schwartz had put in some soil moisture probes to try to, and it's kind of a parallel study where when this dead end was removed, half of it was restored using some of the techniques that we're going to talk about, and then the other one was left as a normal restoration technique. So basically comparing how water is interacting in these two services and trying to basically come up with a way of quantifying like how much water retention improvement is done with using some of these soil restoration techniques. So that's one application. We're also talking about the tech standard possibly being used by developers, kind of putting a site back together again in a way that maximizes water retention, right? So here's, it's just some ideas like we've been, drafting up the first part, and this kind of sets the the background for this. There's been a lot of confusion about what is urban soil health. It's kind of the name itself, and we may end up changing it a little bit. But the main point is that the goal is to restore soils or recreate or create soils in a construction site to maximize infiltration. So it's really a source area control, managing water as it falls, rather than a treatment practice that receives water. So that's the whole idea, and the real idea is then just restoring the upper 2 feet of that soil profile uh, to maximize water retention. So that's where we're at with that, and we're starting to like really nail down some of this stuff. So here's some like what we're this is all draft, but kind of like 7 key site selection criteria, and I think any even a municipality could look at this right now and start to like forecast what lands might be appropriate for doing these techniques. Basically, it's got to be something that can have permanent vegetation that's going to be established and maintained. The bigger one is like it has to be an area that would be protected from recompaction. So like, looking at like a soccer field is probably not the best application. It really needs to be kind of more of a like a passive recreation area, probably where trying to minimize foot traffic, or definitely a vehicle traffic. None of that. Uh, Relatively low slopes, less than 10%. Decent depth of groundwater, minimal utility conflicts. And then this is another key thing: is it's not a treatment practice. It's really managing water as it falls. So there's not any, there wouldn't be a significant run on to these restored areas. And then this is catch-all because we are, in theory, increasing infiltration, making sure it doesn't adversely impact structures. So this is something that municipality, if they were scouting out lands that could be used for this is kind of like some criteria to look at. So here's like probably the main criteria, and again, Stu Schwartz from University of Maryland, Baltimore County, is kind of been our significant expert in this. But this is it's called suburban subsoiling. It's relatively simple operation, applying some compost, deep tilling to about 20 inches, and then putting it back together again and vegetating it. So relatively simple. So it's more of a decompaction technique. And this is why we're thinking about maybe renaming the tech standard, because of all those practices I showed before, this is the one that's kind of like coming to the forefront as the practice, I think, and some related ones. But what's the benefit? So that's another thing that with the goal of the tech standard is actually provide like a credit system. And the benefit is in runoff reduction, but and if you just look at the soil textures on the left side and then the runoff reduction, there's some science. This is based on science from Stu Schwartz's data. But there's some variable benefits, right? So clay, sandy soils, limited benefits, but there's some other soil textures where there's some significant benefits of doing this. So I can envision the tech standard having some table similar to this that applies a variable credit based on the soil texture that you're trying to restore, but it would be a volume reduction credit that gets translated into pollutant reduction credit because we give 100% pollutant reduction credit for water that infiltrates, right? So that's how that would be applied. But the mechanism of how to apply it, we're still thinking about that. But I think the tech standard would have some kind of table like this credit system table. All right, moving on. These are the 2 tech standards that we've completed. Sand filter, dry detention basin. They've been quite a long time in the process, so they are available. I have not seen anybody submit anything for permit applications this spring that include referencing these tech standards yet, but they're out there. We want people to use them. I'll just go through some high points. So the sand filter is really just a type of biofilter, but it is designed to handle more drainage area. There's an emphasis on pre-treatment, but the filter itself would just be straight sand, no compost. It wouldn't be vegetated. But this pre-treatment sediment basin, which is kind of a dry basin, essentially would be vegetated using native vegetation. So it's an alternative to biofilter. It works the same way. Haven't seen many of these. There are some out there in the world that have been permitted historically, but now we have this basically system, and this is a figure right from the tech standard about what the features are. But you'll notice it's very similar to a biofilter with the idea that it's a little more pre-treatment. I'll talk a little bit more about that. I just picked out some kind of high points from the tech standard I talk about. And here's the one that's kind of important in conditions where practice applies. It talks about, treating drainage areas up to 50 acres. I know if you look in our bioretention, it talks about maximizing the drainage area to 2 acres. And I know we've been historically very flexible on that. The concern with larger drainage areas is the accelerated clogging potential. So that's why this particular tech standard, we can look at the general criteria, has these other elements for pre-treatment to kind of deal with that concern of having too much loading to the filter bed. So a little more emphasis on pre-treatment. So that's the difference. But this is a good alternative to think about to a biofilter, especially for larger drainage areas, right? Another thing I want to emphasize is there's a section on, what we call enhanced sand filter media, reference to additives. So this is something that we've been talking about for years, the whole idea that there's a lot of research showing that the compost element of our bioretention system has a liability, at least initially, for phosphorus. So in other words, the research shows that a biofilter with compost in it will discharge more phosphorus than it receives. So this is something we've been talking about, is like with the sand filter, it doesn't have that issue, but then take it to the next level where it actually removes a significant amount of phosphorus, which is a concern, in all the TMDL areas. So this text standard references this additive concept. The way we're going to deal with this is through a technical note. Kevin Kirsch is working on this, and basically the technical note will talk about various additives for filters, including the one that I have over on the right-hand side of the screen, this zero valent iron aggregate from Conley. So this is a product that actually has gone through our additive review, so it's approved for use in Wisconsin. You can use it now. Generally, it's 3 to 4% of the media mix, and a lot of science out of Minnesota showing very effective for reducing phosphorus. So people can start doing this right now, but eventually we'll have a tech note that has more information on this. The other thing I want to reference is, we already have some, as far as credit system, this is already available in our modeling, our post-construction modeling guidance is the credit that we give for a sand filter, 80% TSS, 35 for phosphorus already, just for the sand. But again, adding the iron aggregate could take that 35% higher. So that's where we're heading on that. A little bit about the dry pond. I think there was some hope that the dry pond could be, a standalone practice. I know historically it was practice used for stormwater management quite a bit in Wisconsin. The text standard that is drafted basically has a warning. I put that up in here that it's really unlikely to be like a standalone practice to meet like new development needs, right? It does. I thought this is interesting. The purpose section, what are the, one of the benefits of it is limiting temperature impact. So we know that. I mean, we know like in cold water resource areas, wet ponds are probably the last thing you want to do. So just another option for that. But beyond that, it's not going to be the answer to everyone's problem as a substitute to wet ponds. A lot of the criteria, I just highlighted some in here, is similar to what we've already had in our modeling guidance. And that's what this reference down here is like, how do you model a dry pond? It's basically saying, go to our modeling guidance. So we're not changing anything in this text standard as far as how they're evaluated. There is, I want to emphasize this, there is this kind of like maximum length to width ratio. So trying to create, more of like so they function more like a swale, right? So from the inlet to outlet, a little longer than they are wide, basically, right? So that's where that 2-to-1 comes in, or maximize. So again, this text standard doesn't change the world. It's just kind of reiterating kind of the guidance we already had for dry ponds. All right, moving into guidance documents, there's a couple things I want to talk about, and I just mentioned the post-construction modeling guidance as a reminder, and then the one that we've recently completed is the MS4 swale infiltration basin and dry pond guidance. So this is an important reminder. This guidance is really, it's been out there for years. We redid it last year. This is just a reminder, like everyone should go through this if you're definitely, doing any kind of modeling for new development, redevelopment, for MS4s. This is the guidance document that cleans up the messes that we create when we do tech standards, right? Because they're not perfect documents, right? So we use this guidance document to clean up the questions that come up. And so, like when I do reviews for developments, a lot of times my review are based on information in this modeling guidance. So just a reminder to anybody doing designs, always look at this guidance to make sure you're matching up with that, because the tech standards don't have the answer to every question. So anyway, I just want to emphasize that. And then what I just mentioned with the other tech standards, they're tying back into this guidance document in many ways for the information that are not actually found in the tech standards. So here's one that we recently completed. This is an update of a really old modeling guidance for MS4s from 2010. Initially, it was just for instruction for MS4s on how to model swales. During the update, we decided to include some other practices, and these would be existing practices in the MS4 setting that are commonly used for like TMDL compliance and things like that. So we expanded it for swales, infiltration basins, and dry basins. This is where it's found. It's actually in a weird place. Like if you're looking for it under the normal list of guidance documents, it's actually under the MS4 modeling guidance. And a lot of it is similar to, it's just things we've learned over the last 15 years in interacting with folks doing this kind of work. So a lot of it isn't necessarily new. It's just taking an old guidance document and modernizing it. I did want to mention one thing that we did change. So like one of the main points of the old guidance was allowing for MS4s to do in-field infiltration testing in swales to show that swales are performing better than our kind of default infiltration rates would suggest, right? So, but that existing guidance didn't actually have a specific number of tests for MS4 to conduct. It was kind of a negotiation thing between whoever's doing the work and DNR. And so we tried to apply some criteria to try to increase the science of this effort. What we've learned talking with others is that the accuracy of doing field infiltration testing is definitely based on density. So the more tests, the better. But we realized that if we did like the optimum amount of testing, it would literally be hundreds and hundreds of tests per MS4. So we came with a kind of a compromise, kind of a graduated number of tests based on total length of swale. So we're asking people to follow this, I think, going forward. This is not retroactive. And I have been mentioning, there's some current new planning grants that DNR issued. I think we can, unless someone hasn't really done like a scope of services yet, I think we definitely are not asking people to like redo a scope of services if they've already committed to a certain number of tests. But I think everyone should, even if you're doing, fairly recent modeling, just take a look at the guidance. There's some other things in there that may not affect the cost of the project, but this thing might. So this is definitely something for future efforts. We want people to think about doing these things more frequently than they may have in the past. So these are just some MS4 permit reminders, talking with Sam and Lexi about some things that are happening. Just a reminder about that the new MS4 general permit is coming up relatively soon. You're going to start seeing that. It's been worked on for a while. In Southeast Wisconsin, we have a lot of individual permittees, so it doesn't affect a lot of Southeast Wisconsin, but a lot of the state is under the GP. So that new permit is coming soon. Just a reminder about the BMP menu. I know we've been talking about it from time to time, but I think it was a really good effort to provide more or less examples for MS4s about the various programs that you're trying to implement. Something we should have done many years ago, but a great resource for MS4s to see, basically what others are doing. Is always good to, take a look at your programs and try to make them better, right? And this is a good resource for that. The other thing that I was going to mention is that EPA is going to be doing some audits in Wisconsin. I don't know if they've selected communities yet, but some communities are going to be, and this would be done, with DRNR participation. But EPA Region 5 is going to do MS4 audits in Wisconsin in the coming year. So stay tuned for that. All right. So I know I'm getting near the end, so I want to do some other stuff, including an opportunity to include some of my favorite pictures that I will put in the category of other stuff, but really real other stuff. There's a couple things that I want to mention. I don't. Some of you probably know this. Like when we get an NOI at DNR, we have two archaeologists that screen all the sites for possible historic buildings and for archaeological sites. And then some of you get one of those wonderful emails from somebody at DNR saying you need to do an investigation. But they've been pointing out recently, our archaeologists, that there's been several sites that have been flagged for historic buildings. And then when we ask questions, we're told that, oh, that building was taken down like 2 weeks ago or last year. So we're going to do some outreach. This is kind of a draft of something you're going to see by Gov Delivery and a couple other mechanisms. Just some reminders for folks, especially for historic buildings. There is information already available at the Wisconsin Historical Society for things that are described as historic buildings. And what we're trying to tell people is that, demolition for an NOI is part of the construction site. So it's not something where someone can, like do a demo and then get their NOI. It's basically, if there's land disturbance associated with a demo, it needs to be part of our permit, and then it'll get reviewed by our archaeologists, and they may have some requirements before the demo occurs. So we just want to, so this doesn't happen as much anymore. We just want to let everybody know, like, yeah, I mean, please try to screen your sites for possible historic buildings and try to avoid demoing them before getting your permit. I think that's the message here. So you'll see more on that. And I think I'm just going to end. I know I'm running out of time, Leif. I know a lot of you guys went up to Fox Wolf a couple weeks ago. I thought this is really interesting effort. Dane County Land Conservation Department has been putting out or has put out some flyers for stormwater practice maintenance that are meant for, basically homeowners, private owners, people who don't know much about these things. And they have a whole series of them. I just included a couple here, and they're more than willing to share them. It's on their Dane County Stormwater Manual. I thought these are a couple interesting ones. I just, did some covers of these are several, a few page flyers, but they have a flyer just on inspection requirements, right? Which is probably very helpful to anybody that's doing this. And then they had a special flyer on like vegetation. And we've noticed this even locally, like when I've driven around just for fun, looking at biofilters, like the quality of the vegetation is not as we would hope, right? And they've did the same thing and basically uncovered, which makes sense, that a lot of times it's not that people don't want to, it's just they don't fully understand what they have, especially for like private owners, right? So anyway, so I just wanted to highlight they have these resources, and Waukesha County has their own. These resources from Dane County, more practices, more information, I think. So like as a package, I think really helpful. And it's something that we've been talking about for the last couple of years, like trying to improve the maintenance inspection of private BMPs. It's a huge issue for the stormwater world. We're still talking about it. We're actually going to be meeting with the Metropolitan Builders Association in a couple of weeks just to talk about maybe where their role is. So I think that's my final message here today is just, let's keep working on this. We know, we spend a lot of time up front on the permitting and construction, and like, are we missing the key component is making sure all these practices that we permitted, installed are functioning properly. And I think it's still a gap that needs a lot of work. And this is just part of it, some educational element is just a part of the way to try to improve this so that someday it's, not kind of this big liability hanging over the stormwater world. So with that, I think that's it, Leif.
Question from the chat. Is there any potential schedule for refreshing the 1003 infiltration basin tech standard?
That one's not on the radar screen. Just to give you guys a little inside information, like we work with the Standard Oversight Council, and we do propose new tech standards every year, but we can't work on more than two at a time. So that's why you kind of see these things in groups of two. So the problem is like, that one's hasn't been like widely requested. So if we're only working on two at a time, and I mentioned a couple of the other two that are coming up, and we're already working on one right now, it's just like, yeah, I can't imagine that being like soon, but like we do, and maybe you guys have seen it, like SOC sends out a like a survey asking what we should focus on, and we definitely use that as kind of work planning. But that particular one, I think, is not coming up as like a high priority. We'll probably do like the wet pond one because that's getting old, so that one would probably be refreshed. But again, like start projecting this out. Like if we can only work on two at a time, and we've already got like a couple in the hopper, it's going to be a couple, several years before you get to those. Um, but
Um,
thanks for the input.
you mentioned the new guidance on process for evaluating swales and so on. Just out of curiosity, what does it say about minimum infiltrometer size?
Well, okay, just restate that, Leif. I clicked on
How
something
big
I didn't
does
hear.
a double ring infiltrometer have to be? I think the ASTM standard says 24 inches.
Yeah, right. I mean, so yeah, we're trying to stay away from like, and we talked about this, like, do we have like a list of accepted field infiltrometer methods? And we're trying to avoid that. But every method has its own, like, I guess, diameter, right? And we're leaning heavily on the research that Minnesota has done. They've tested and evaluated all the different methods. And most of them have their pluses and minuses, but we haven't, we're trying to avoid having a list of approved ones, but the ones that people are using, like double ring, MPS, the ones that people know about, I think we're fine with. But that'll be revisited, I think, as time goes by. But right now, we're trying to avoid like saying a lot about it. Um, there's, we've been told, I guess there is some possible connection to like the diameter of the device on the accuracy. But then I heard somebody else mention there's some other factors. So I think that's to be determined. But right now, I don't think we're being like overly prescriptive about the methods that are used.
The reason I'm asking is in part because we've got my department has a 24-inch infiltrometer, but I know from bitter experience it is physically impossible to pound it through
Yeah.
grass roots.
Yeah, so that's where these other practices definitely, the other option testing methods have less diameter, and that should be fine, right?
Yeah, I
There are
remember
ones with
Roger
smaller ones.
Bannerman was
Yeah.
skeptical about small infiltrometers, but
Yeah, I
the
think
thing
that's
is they're
basically from the work that Minnesota's done. I think we've moved on, and then they have some published papers on this if you're interested. But I don't think,
but
yeah, the
I
double
remember
ring was kind of
seeing a
the
John
standard.
Gulliver presentation
Yes,
where he said, they make up for the size of the infiltrometer by literally doing dozens and dozens of tests.
yes, right. So I mean, I think we moved on from like it has to be double ring infiltrometer, and there's nothing else. We've definitely
Mhm.
moved on from that. Um, yep.
Well, thank you, Pete. Lots
Thank
to
you,
chew
Leif.
on there. I know I pretty imagine pretty much everybody's got your email if they have follow-up
Sure.
questions. So,
Yep.
um,
Sounds good.
thanks very much for your time.
Thank
Great to
you.
see you as always.
Yep. Thanks, Leif.
All right. Next presenter is Rick Eilertson, who works at AECom. Rick earned his Bachelor of Science degree from UW-Madison in 1993 and has worked in the municipal engineering field since 1990. He's the president of the American Public Works Association Wisconsin chapter and is a past chair of their Water Resources Committee, also, and their Solid Waste Committee and Sustainability Committees. He currently serves as a knowledge team member on the APWA's International Sustainability and Resiliency and Water Resources Management Committees. Past awards that Rick is especially proud of are the 2013 APWA International Community Involvement Award and the 2015 Rock River Protector. And Rick is going to be talking about um, stormwater utility fees and credits and how to incentivize private stormwater facilities without breaking the bank. In other words, sticks and carrots, I believe. So, Rick, I'm going to turn it over to you, and I will disappear and pop up in about 20, 25 minutes.
Great. Thanks, Leif. And thanks so much for putting this on. It's always a fun workshop to join. So gonna get into it. So I've got here's my son Evan pointing to the learning objectives that we have for this session. So describing how to access the rate structures and the credit policies for stormwater utilities throughout Wisconsin. I'll get some references to national stormwater utility data as well. And then compare pros and cons of up to 3 different credit policies for various stormwater utilities in Wisconsin and how they incentivize the inspection and maintenance of private stormwater infrastructure. And then finally, evaluate potential enhancements to existing credit policies that ensure those private stormwater facility owners are doing their part without breaking the bank of the municipality. So first, some stormwater utility basics. A lot of people probably are familiar with these, but essentially it's just a different way of managing the finances for dealing with stormwater management for community. So it's a local government program that funds stormwater management. Generally, historically, prior to 1994, when the first stormwater utility was created in Wisconsin, everything was all the stormwater management tasks were paid for out of property taxes. So generally the fees are based on the impervious surface and gets down into that residential equivalent runoff unit. So kind of the average residential impervious area. They are authorized under Wisconsin statutes now. The first ones didn't have references to that, but as the legislature has seen that these stormwater utilities were being created, then they encouraged PSC or the state to start creating statutes that would govern rates if they were challenged. And then generally the non-residential properties are based on multiples of the impervious surface area. And I guess the average typical ERU is 2,500 to 3,000 square feet. There's some that are less and some that are more, but that's kind of the average. So there's a couple of different references in state statute. These specific numbers for how you can establish a stormwater utility if it's not already established. One of the key caveats is generally they're not governed by PSC unless there's a challenge, and if it is challenged, then oftentimes PSC will get involved, review the rate structure, and identify if it's a reasonable rate structure. One of the things that PSC has weighed in on is that if you've got a decent credit policy and appeals and variance process, it's pretty rare that PSC would then take over administration or the review of future rate increases, but it does happen. It has happened for a couple of different communities. So accessing rate structures and credit policies, one of the organizations that's done quite a lot of work on this has been American Public Works Association, and big shout out to Jeff Mazanik, who kind of led the charge early on in the early 2000s up to about 2016 when Jeff passed it on to me to help manage. But basically, if you go to the Wisconsin chapter American Public Works Association website and then go to chapter committees, click on that, and then down on the go to Water Resources Committee, because that's the committee that's been leading the charge on making updates to the stormwater utility rate structures in Wisconsin. And then down at the bottom of that page, right, you can click here and you get to that. It's just a PDF of the spreadsheet that we got. There may be some enhancements that we'll make to the website, but generally it's going to be at least there'll be a copy of it housed at the Water Resources Committee webpage. So here's just a snapshot of the beginning and end of the stormwater utility fee and credit information spreadsheet. This is just what we've got in the PDF. There's also quite a lot of other information that the committee has been gathering that's off the screen. But basically the name of the community, population, when the stormwater utility was created, And then the ERU size that they've got. Some communities don't publish their ERU size, and and then the annual dollars per ERU or single family home, basically. And so you can see there's quite a wide range of fees per ERU. And again, part of that's based on some communities have slightly different ERU sizes. Then we also have a question for whether or not the community has a credit policy, and then if they do, what the maximum amount is for that community. Have a website address, so if people want to, these are all clickable, so you can go and take a look at the community itself. And then we also have a column, just the last date that that some of these were confirmed. Jeff and the Water Resource Committee, when I was chair, did a major overhaul back in 2015. So we had all of the communities updated at that time. So it's a little over 10 years ago. We did a partial push 5 years ago, and we're hoping to re-up, get everything updated up to 2026 within the coming few months, possibly before the spring APWA conference that'll be in Brookfield. But this is my home email, and you can forward any updates that you got to me there, or you can send it to my AECOM address as well. One of the things that I just looked at prior to the Sweetwater conference was I found the Western Kentucky University Stormwater Utility Survey. So Western Kentucky University has been doing updates of stormwater utilities throughout the United States for quite a while. Here's a reference to that document. Warren Campbell is the professor that's been leading that charge, and he has students that have been digging into data and updating that. This is just an inscription in the acknowledgments for the survey, acknowledging the work that APWA has been doing, the Wisconsin chapter has been doing for stormwater utilities in Wisconsin. And when I went through that just a few weeks ago, found 4 additional communities that we didn't have in the APWA Wisconsin spreadsheet. So now we're up to 129 based on the current data that we've got. Another reference back 2015 to 2016, Steve Kemna, at the Public Service Commission, had done a pretty deep dive into rate structures. At that time, he had found 120 stormwater utilities in Wisconsin, and here's a summary of the presentation that he gave. But he really dug in pretty heavily into the credit policies. So I'll show that in a little bit. But basically, here's a summary that he had provided in the presentation that he had available back in 2016. And again, he really identified that having a good credit policy is key to reasonable rates, as well as the ability or the reduction of chance of PSE taking authority over the review process. Here's just a snapshot of a number of the different things that are kind of in the back end of that spreadsheet based on the work that Steve had done. So he had a number of different questions that he asked individuals from each of the different communities back in 2015 and 2016. So does the utility offer credits based on numerically defined hydrologic data? And yes, no. And then maximum credit. So this is a little bit in addition to what we had already in the spreadsheet, and then a number of different other questions that if anybody's interested in that minutia, can feel free to let me know, and I can forward that spreadsheet to review and update and refresh if you're able to. So back in 2015, the median annual charge, so basically the average charge for a single family home, was just under $62. And just the combination of the 2015 to 2023 data now shows an average of 77.5 bucks per ERU per year. And I suspect that once we get actually this should be 2026 data. Once we get everything updated to 2026, I suspect that that's going to be probably in the $80 to $90 per ERU per year for an average. So digging into a couple of different, three of the stormwater utility credit options that I'd run into. Here's the city of La Crosse. So La Crosse established their stormwater utility in 2012, and they've got an ERU of 2,841 square feet, maximum credit of 80%. And you can see the changes over the years in they didn't have any change until just this last year. They did a big push, reevaluated their fee structure and went from 54 bucks a year to 140, basically $145 a year. So a big jump in there just in the last couple of years. And then you can see they've got there's a link here for stormwater utility credits and forms, and these are the different. There's 6 pages of policy for the stormwater utility credit that they've got. They have separate credit application forms for non-residential versus residential. You can see the number of pages that each has. This is the residential sign up sheet. So pretty minimal amount of information that's shown on this sheet, but you have to attach documentation of any best practices that you've got on that help meet the stormwater requirements for the community, and then they'd the community the representative from the city would go out and inspect and verify that it's that what we have in place to then potentially offer the credit. Another one is the City of Madison stormwater utility fee. So Madison created their stormwater utility in 2001. They basically have I think they actually have a full acre lot for their ERU, which is basically the lot area, sorry. And so they don't really have a specific square footage. Their maximum credit varies. You can see the rate structure that they had from 2019 up to 2026, another pretty big change. They really hadn't, prior to this last update, they really hadn't had much for private credits. Part of it is they basically required that I think the stormwater facility need to be designed for up to 100 years design storm, which a lot of certainly residential properties generally weren't designed for that. And then obviously they need to have a professional engineer sign off on it as well, historically. So they have made quite a bit of changes to their policy just in the last couple of years. There's actually 5 different options for credits that they have available. And these are the forms. So the 7 pages of credit policy form that describes each of the different 5 options, and then just a 1-page for they also call, a number of communities call these just rate adjustments rather than credits, but basically they're pretty well synonymous. And then I think primarily Phil Gabler is getting these, so the forms go to the stormwater utility, and Phil is, I think, primarily the one that reviews and will back check which items are on site, and then he's actually just developed a spreadsheet just recently to enter in the data, just because it's at least in my opinion, it's a kind of complex equation for how the credit gets calculated. And then the third one that I'll talk about is the City of Fitchburg stormwater utility fee. So their stormwater utility was established in 2002. The ERU is 3,700 square feet. They've got a maximum credit of 50%. Currently, they had been thinking about bumping that up to, to 75% if people met infiltration requirements, just because that's something that's hard to do oftentimes on a regional basis. That just hasn't happened yet. Then you can see the fee structures that have been in place from 2019 to present. Again, a pretty big jump in the costs. And Fitchburg's got a fairly robust credit policy that I'll go over here. So right now the policy is basically just this one 2-page form. Describes, so the property owner would need to fill in their utility account information, name, address, and then check which item that they've got on their property. So this is the residential component, and then this is the multifamily and non-residential component. Basically, they'd check off which item they've got, and they do have this Fitchburg Creek Supporter Pledge Program, so it's an additional credit if the property owner for both residential and multifamily non-residential. So an additional dollar amount that they can get off. Here it's per quarter, but basically through the just additional credit. So here the dollars that can be reduced by rainwater harvesting. If they meet water quality criteria, then they get a maximum of 25% reduction, and then a water quantity, so peak rate control or infiltration is another 25% off. And then pervious pavement systems, basically they reduce the ERU based on the amount of the pervious pavement system. And then finally, they've got a Creek Supporter Pledge program that runs up being $4 to $8 per year per property. This is kind of unique. I worked for the city of Fitchburg for 10 years, and while I was out in Walla Walla County, Washington, I ran across this Streamkeeper document that just had, like 30 some practices that people can do right on their own properties. And so I liked that a lot. They had these first 8 categories in there, just best practices related to that. And a couple of years after this was established, then I added in urban forestry, because we know that urban forestry, can have a very positive impact on if it's done right on stormwater reduction, stormwater runoff reduction. So there's a 9-page form that basically runs through the best practices, and the property owner then just check off the best practices that they're willing to do on their property. And if they get at least 34 out of the 57 recommended practices, they get an additional a credit on their stormwater utility fee. Here's a couple of examples that Fitchburg had. So here, back in the early 2000s, this is a private dry detention basin with a concrete channel running through it. The owner of Promega, the property owner in this area, really didn't like the look of the dry detention basin. Talked with Rob Montgomery with Montgomery Associates Resource Solutions, and said, "Hey, I want to change that." And Rob and a professor from UW-Madison basically worked on designing a bioswale through the property, took out the concrete and made a meandering bioswale through there. And here's a couple of examples. We've got some signage, which is kind of nice to describe that. I later took grade school students through here, gave them bags, and then they were able to, with permission from Promega, they were able to gather seed, and then we took the seed back to the grade school, and then they were able to plant the seed, and ultimately we converted a dry detention basin in front of the Leopold Elementary School into a rain garden with plants that the students basically were able to grow from the bioswale. But basically, there's about $10,000 a year for the property owners that all drained into this, that they were previously paying for a stormwater utility fee and the credit, they met the full 50% reduction. So $5,000 basically was reduced, and that effectively paid for all the vegetation management. So occasional mowing, but they actually did quite a lot of prescribed burns through here, and really, in my opinion, a very successful private stormwater facility that's been managed very well. And again, the credit policy helps to incentivize the property owner to do that maintenance and then report on it too. So reporting the inspection is another big part of that. Some just additional photos of the site. Another facility, this is in Fitchburg, is the Crossing Ponds. So this is a regional detention basin that's a wet pond with 15 rain gardens that drain around, that are around the property, but a large, actually two pond system that the city actually coordinated the original construction, and then after 3 years of vegetation management by a city contractor, then that was turned over to the property owner. So again, a pretty similar amount of impervious area, so about $10,000 to the property owner, the crossing condominiums paid into the stormwater utility fee. And after the credit policy was implemented, they were able to reduce that by about $5,000, which similarly paid for the regular ongoing vegetation management for the stormwater facilities. You can see Steve Banovitz here just kind of pointing out a lot of issues with the property manager understanding, what areas should be mowed versus what areas should be left with native vegetation. But generally, it's been a fairly successful, after quite a lot of discussions with the property manager, got them to understand what we were looking for, and it's another pretty good example of private stormwater infrastructure that's being maintained well. You can see the prescribed burn that we did. This is actually when we turned the vegetation management over to the property owner. So we had a meeting with the property manager and several members of the condo association, just to help make sure that they understood what they were getting out of the stormwater utility credit policy, and then what the requirements were to pay for and conduct the ongoing annual inspection and maintenance. Just a shout out for the upcoming spring APWA conference. We'll have some additional, a little bit longer session on this topic at that conference, and the Water Resources Committee will have a committee meeting that Thursday, the 23rd. So if you're interested, feel free to join. That's all I got.
Cool. Just a reminder, if you have questions for the presenters, please post them in the chat, and then I will pass them along. Rick, in listening to that, one question that occurred to me was, it looks like some really neat programs to try and get residents and so on to do BMPs on their properties. But I was thinking from an engineer's standpoint, okay, so you got a neighborhood where, say, a third of the homes have rain gardens. How do you include that in your SLAM model?
Yeah, so the benefit of generally most of these credit policies require that the inspection and maintenance to be provided in a report, at least on an annual basis. Some practices need to be inspected and maintained more often than annually, but at least the one summary report. And so obviously it could take a little additional work to model it, but we've actually come up with some nice ways. There's a database modeling that you can just plug and chug. It takes some time to set up the WinSlam model appropriately to begin with to accept that, but there's some easy ways once you've got that set up to plug and chug those improvements for those particular properties.
So you would use, like a standard land use file or something like that for, say, a neighborhood, but then in the under source area BMPs, you would insert rain gardens or what have you as being an initial treatment step.
Yep. Hmm.
Okay, cool. I was a little startled when I saw that some of the utility fees went up by like 80% over 6 or 7 years or so. That had
Yep.
to be pretty unpalatable to some residents, I would think.
Yep. Yep.
Yeah.
Well, and probably, the bigger, if you think about that's what the residencies, the industries that have, larger, impervious areas see that even more, but they don't vote. So
Yeah. Great, Rick. I really appreciate your taking the time to present. That was really interesting.
thank you.
Okay. All right. Thanks very much. Next up, we have Daniel Johnstone and John Lindert, both from Strand Associates in Madison. Daniel holds a biological systems engineering degree from UW-Madison and serves clients throughout Wisconsin. His 4-year career is focused on a number of project types, including MS4 and TMDL compliance, stormwater quantity analysis, green infrastructure, stormwater grant writing, wet detention basin dredging, and stream bank and natural area restoration. In his free time, Dan enjoys rock climbing, skiing, snowboarding, biking, and going on runs. And John holds a civil engineering degree from UW-Platteville and serves clients in Wisconsin, Illinois, Iowa, Kentucky, and Ohio. His 33-year career is focused on planning, analysis, and design for stormwater quality and quantity management, MS4 compliance, green infrastructure, sustainable design, floodplain management, stream bank and natural area restoration, and park and recreational facility design. He's a past president of the Wisconsin section of ASCE, past chairperson of the CSWEA Wisconsin Watershed and Stormwater Committee, and serves as a Rock River Coalition board member. And in his free time, John enjoys single track mountain biking, native gardening, and muskie fishing. So neither of you is a bungee jumper, I take it.
No, Dan would probably be the closest one. He does rock climbing. So,
Okay.
uh, all right. Well, thanks, Leif. Today I'm going to talk about MS4 TMDL success story, how Stoughton gained compliance without breaking the bank, um, with Dan Johnstone, and we'll just get right into it. From an agenda standpoint, we'll first talk about some Stoughton history, talk about some introduction, some work we did on stormwater BMP field reviews, stormwater quality modeling. That was key to what we were doing. We'll look also at alternatives analysis, including BMPs in the city and water quality trading and watershed adaptive management kind of summary, and look at an implementation plan that we did and some key takeaways. First of all, some Stoughton history. If you've been in Dane County in the spring, you know that there's a Sudeten Mai festival that celebrates the Norwegian heritage of Stoughton. In fact, Leif, do you know who the cross-country skier from Norway that won all those medals was in the Olympics?
Uh, Johan starts with a B.
Klebo, right?
Weibo, yeah.
Yeah. He's not from Stoughton, but uh, figured he might have some connection to Stoughton, but not to be. Stoughton also has a rich tobacco history, if that's a good thing or not. There are a lot of drying sheds for tobacco out in the landscape. And one of the interesting things more recently on a water quality side is the Har River Park shown here on the bottom. Um, where they want to convert a dam to a whitewater park for kayaks and canoes, kind of like they have up in Wausau. And this has really heightened their interest in stormwater quality, especially at outfalls upstream of the location here. And Dan will talk a little bit more about that. And of course, Stoughton is just southeast of Madison, 15 miles or so, with a population of about 13,000. From an introduction standpoint, of course, the city is a MS4 permitted community. They've had a long history of doing stormwater plans and updating those plans and kind of keeping up with the DNR policies and guidance and credits. Most important thing probably here for TMDL compliance is the REACH information in terms of Rock River TMDL compliance. As you can see, we have 4 reaches here. TSS reduction requirement ranging from 40 to 62% and TP reduction ranging from 27 to 80%. Much of the city is in the 67 and 68 reaches. So the requirements there are onerous, but not outrageous, I guess. Stoughton timeline shows commitment to stormwater quality and grants. Here we show a timeline really starting back in 2010 where we put together a stormwater utility feasibility study and got that implemented to help fund the program moving forth. And you can see kind of a sequence of in green grants that fund in blue the stormwater plan here to begin with, and a TP leaf credit collection credit analysis, and as well grants funding design and construction of dry to wet detention basin and a hydrodynamic separator, all completing being wrapped up with a final planning grant and a stormwater plan here from 2024 to 26 showing which you'll find complete compliance with the TMDL. Another way to look at that timeline is to look at the different things we did and some of the dollar amounts that were involved. The important thing on that top table is engineering amount of all this was $568,000. Construction cost was about $753,000. And then these are the different grants that we got through Urban On-Point Source and the Dane County Urban Water Quality Grant. And the table on the bottom left showing, again, these in a different format, but the total city investment being $661,000. So 50% roughly, and grants being 50%. So real kind of affordable way to get into TMDL compliance by leveraging grants. The city stormwater quality plan progression is kind of shown here. First of all, on the right, the different reaches. Reach 67 is right in through here with the bulk of the city. Reach 68 down here, and then some small amounts of 69 and 66. But back in 2010, an original plan was done, city at 29.6% TSS and 20.3% TP reduction. Our update of that plan in 2018 showed this 31.7% TSS reduction and 27% TP reduction, requiring 2 to 5 million in BMPs, depending on which alternative you looked at. And in 2026, we updated this again with a lot of things that have been going on, which Dan's going to talk about between the 2018 and 2026. City now at 49.6% TSS and 45.6% TP reduction, noting that reaches 66, 67, and 69 became in full compliance, but reach 68 did not. But because reach 67, which was above reach 68, we could trade excess pollutant down to reach 68 in an internal trade. And thus the city was in full compliance. Again, this plan that we are currently finishing up is funded by, again, an Urban On-Point Source grant with the numbers you can see there. And we updated a portion of the stormwater program kind of in this tan or greenish color. We did some public stormwater BMP field reviews that Dan will talk about, some wind SAM modeling and alternatives analysis updates, and updating the stormwater system map. With that, I'll turn it over to Dan to dive into a little deeper into all this.
Alrighty, thanks, John. So yeah, let's first talk about these existing public stormwater BMP field reviews that we completed. We had 8 BMPs reviewed to comply with pollution prevention municipal operations permit condition. You'll see these 8 BMPs here. You have 6 wet detention basins, an infiltration basin, and a bioretention basin. So to dive kind of into one of these as an example, there's actually 2 of them here. City approached us and wanted to have us review these 2 BMPs because they're part of kind of a larger development. That's not fully complete yet. You'll see a wet detention basin on kind of like the left-hand side, the west, and then an infiltration basin on the east. So we did kind of these BMP field reviews consist of kind of a typical BMP inspection that you have to complete for these BMPs, but then also kind of a more in-depth review, including sediment depth surveys, top and bottom of sediment, things like that. And then for infiltration basins, things like infiltration rate testing and things like that. So kind of two components that we'll talk about here in a second. So here are the 6 wet detention basins. It kind of shows the sediment depths that were measured, and then kind of the year is constructed, and then kind of from there you can calculate how quickly these BMPs are filling up. And then kind of on that rightmost column, you can see kind of a predicted year of when it will be in need of dredging when there's less than 3 feet of water depth remaining in the wet detention basin. So this table kind of provided the city and kind of acts as a kind of a planning document for the future. So for the infiltration basins, I don't know if you noticed on the previous or 2 slides ago, there's the infiltration basin actually had standing water in it, and the city had kind of an intuition that this basin was not performing kind of how they anticipated, and you can kind of see that in the results here. So we'd performed an MPD infiltrometer test on this basin, and you can see the 3 locations that these were performed at, 1, 2, and 3 there, each having different hydraulic conductivities, and kind of the average of the 3 was used for the overall basin, and that was 0.73 inches an hour, which is definitely less than the 3.6 inches per hour, which is required by the DNR. So as the city kind of guessed, this was definitely an infiltration basin that had been clogged. You can actually kind of see that in that there's 0.3 feet of sediment kind of above where it should be when they surveyed kind of cross sections of the pond. So this one was definitely a clear, like, okay, this needs to be dredged or kind of remediated pretty quickly here. And then the other bioretention basin had an infiltration rate of, or a hydraulic conductivity of 13.63 inches per hour, which was above that 3.6. And there was no such kind of sediment accumulation in this one. So then let's talk about the kind of double ring and the modified Philip Dunn MPD infiltrometer comparison. So these can be used for swales, kind of like we kind of discussed earlier on. But you have the double ring infiltrometer on the left here, and then the MPD infiltrometer on the right. Double ring, as we stated previously, is kind of like the more standard approach, and this MPD is a bit newer. So let's run through kind of some of the comparison of the two. So the double ring always takes 2 hours. That's the test. While the MPD is kind of soil dependent. So for sandy soils, you're taking 5 to 10 minutes to test. Up to clay soils, 1 to 2 hours, if not longer. And that double ring for a sandy soil could take 50 to 100 gallons. So you'll see in that left picture there, you got the truck kind of hauling quite a few large barrels of water that could be used in these tests. So it was really quite cumbersome to haul these around, and you couldn't obviously move them away from the truck at all. So kind of hard to reach different locations and things like that. And you can only do 1 test at a time. While the MPD, you could run 3 at a time if they weren't infiltrating quickly. But typically, I mean, in a sandy soil, it takes 5 minutes to set one up. So you're kind of stuck at 1 to 2, but you can do them pretty quickly in multiple locations per. So then with the testing of the double ring is the infiltration rate, while the MPD is the soil conductivity. And then the calculation method for the double ring is by hand or using like Excel, while the MPD uses kind of a computer automated device. And then you'll see the results here on the right. So the MPD came in at 13.3 inches per hour on this bioretention basin. And then for that same bioretention basin, we came in at 13.95 inches per hour on the double ring infiltrometer. So obviously sample size of 1, but those are pretty close to each other. And we were kind of pretty happy with how close they were and that the MPD was slightly more conservative. So as I mentioned, we also did BMP kind of inspections for each one of these 8 basins. And here you kind of just see kind of a summary of all of that. Are there pipe fixes, erosion control, remediation needed, dredging? Those are the sorts of things that we kind of summarized here. And this gave kind of a shorter term to-do list for the city to kind of complete. So stormwater quality modeling, this was kind of like the biggest portion of this project. It's all kind of summarized in these 2 figures here. You have the baseline, no controls condition, and the existing conditions with controls. And the red obviously has the highest TP loading per acre, while the blues and greens have the lowest TP loading per acre. So the areas that are already getting high treatment and existing conditions are the ones that have kind of gone to those blues and greens from the yellows and oranges and reds on the left-hand side. So you can see there's quite a bit acre area that kind of has that high treatment that we'll kind of talk about in a bit more. So as John mentioned, Reach 60, 66, 67, and 69 were in full compliance, and that Reach 68 wasn't. But for both TSS and TP, the gap that 68 had was less than the excess that Reach 67 had. So the city was able to do kind of an internal water quality trading from upstream to downstream to cover those gaps. So let's also talk about kind of the stormwater best management practices that were implemented since 2018 that kind of helped the city come into compliance. So we had the enhanced street sweeping program, which had a vacuum street sweeper purchase from the WDNR UMPS construction grant in 2020, TP leaf collection credit analyses performed in 2020 and 2025, before and after the kind of guidance update that occurred in 2022, the Paradise Pond monitoring that led to 88.8% TSS reduction for the Paradise Pond and then to 78.3% TP reduction. The city performed an industrial park dry to wet pond conversion, hydrodynamic separator installation. They had a number of new developments, redevelopments, and then also other kind of B&P modifications, which we'll all dive into here in a second. So the TP leaf credit analysis, the city, like I said, performed two before and after the credit update in 2022. They used the vacuum street sweeper purchased in the 2020 grant. And the grant was $54,000 for that purchase. And this allowed them to have street sweeping once every 2 weeks with vacuum street sweepers. You'll see that the kind of updated modeling guidance led to an additional 40 pounds of TP in some reaches, and then kind of total about 45 throughout the city. And they were able to meet this requirement largely because of their street sweepers, but also because of their leaf collection trucks you'll see on the kind of bottom right there. This photo is them taking up leaves off the curb and gutter, but it also is used to take the leaves off the terrace kind of during a majority of the sweeping and kind of collection process. So let's dive into the Paradise Pond monitoring. So this wet pond is kind of an internally drained wet detention basin with 11-acre surface area. You'll see that watershed map in the bottom right. There's a lot of kind of undeveloped area in that watershed in the aerial, but that's kind of an outdated aerial, and just about all of that has become developed since then. So the pond is discharged only via hand-operated stormwater pump. So the city goes out there and turns on the pump and then turns off the pump. So it's kind of hard to model that in Windslam. So in the permit requirements for the 2019 to 2024 MS4 permit, there was a requirement that the city perform monitoring of the pond over those years. So at the time, before the monitoring was complete, the wet detention basin was getting 82.1% TSS and 56% TP with a weir outlet. And then we'll kind of dive into a bit more of like what the updated numbers were. But here you can see the large pond, the submersible pumping station nearby, and kind of where it is. So from 2017 to 2021, the Paradise Pond monitoring was completed. They did a stormwater quality monitoring and sampling, which is kind of where they sampled at the wet well and the force main discharge twice during each pumping event. And then they also did a stormwater quantity monitoring where they used pump run times and wet well surface elevations at pump start and stop to calculate the total volume pumped out. And here you'll see kind of the pumping location or the sampling locations, and then kind of the stage storage that was used to calculate volumes that were reduced. And then we also kind of highlighted where in their permit they had to perform this monitoring, kind of the requirement there. So this is kind of like a overall summary table of all the data that was collected over these years. Each location, TSS reductions, loadings from the calculations, and then different options that were kind of calculated based on rainfall and average rainfall. And it all came out to that option 2, 88.8% TSS and 78.3% TP reduction, which we'll talk about in a second. So kind kind of a brief rundown here. You have the volume calculation of you have the direct volume, which uses the stage storage, and the pumped volume calculations, which use pump on and off. And so you have your volume, your two known volumes, and then you have your pollutant sampling. So that gives you a loading calculation. You can compare that to the WinSlam baseline loading, and that can kind of get you your TSS and TP reduction for the pond. And then what happened is that obviously rainfall isn't average every year, and you're comparing it to a WinSlam average rainfall. So there were a number of different options of how to kind of average things out. But what it came out to be was 2018, 2019, the 2018 and 2019 rainfalls were excluded because they were higher or significantly higher than the average annual, while 2017 was slightly above and 2020 and 2021 were slightly below average. So these were the 3 years that we used kind of sampling results for to calculate the 88.8% TSS and the 78.3% TP. And you can see obviously there's a jump in TSS reduction and TP reduction from this modeling. So the industrial park dry to wet pond conversion was completed. You can see kind of the before and after, or the before here, inlet and outlet is pretty heavily overgrown with cattails. And this was identified in the 2018 Stormwater Quality Management Plan. And you'll see kind of like the original draft up that we did for that plan of this dry to wet pond conversion. And that dry to wet pond conversion had a 39.6% TSS reduction and 29.0 TP reduction, which came out to about 30 pounds of TP annually. And it drains about 166 acres of residential and industrial lands in Reach 68. So here's some after photos of the inlet and the outlet. You'll see it's been widened. You got the wet pool in there. It cost $380,000 for the city, including engineering. And between the two grants, the city cost came down to $145,000. So they only paid about 38.2%. So they were able to kind of leverage these grants to kind of implement BMPs in areas that they needed it to reach their compliance goals. So they also installed the hydrodynamic separator on Washington Street, which is upstream of that Yahara River whitewater park that John had mentioned. So these were areas, and we've kind of analyzed a number of these where it's residential areas or other land uses that drained straight to the Yahara River without treatment and no way to really treat these things besides hydrodynamic separators. So the city's goal was definitely TSS and TP reduction, which you can see the numbers on the screen there, but it was also the trash capture and the grease and oil control upstream of this park. So this hydrodynamic separator treated 46 acres of residential land and is kind of a tool to help kind of remove trash and other debris before getting to this park. So here's kind of a after and kind of during construction photos. You can see the lamella plates that Stormtrap Sightsaver uses kind of there on that middle picture, those kind of slanted metal slots. You can put those into WinSlam to get higher treatment because of kind of a wastewater issue there, but definitely an interesting thing. And they have $373,000 for total costs, and the city share was only $51,000. So a lot of grants to help them out there. Quick comparison of the different hydrodynamic separator types. You have the manhole structures and the box structures. We'll kind of go through the pros and cons of each of these on the next slide. So you have kind of common manufacturers for the manhole structures were Contact, Oldcastle, and some others, and then the box structures. Stormtrap was also kind of included in that list. But manhole structures have lower cost and lower treatment, while box structures are typically larger, so they have larger cost and larger treatment. The manhole structures are typically smaller, and they can place in place of a manhole, which is great, but they typically can be undersized and require diversion structures and have less pollutant reduction. While the larger box structures have larger sizes, can go on online systems for larger watersheds, but they are more costly due to the larger sizes and can cause more utility conflicts. Like I said, the manhole structures can be online for smaller watersheds, while the box structures can be online for larger watersheds, and they can both capture floatables such as oil, grease, and trash. And then we showed those hydrodynamic separator with lamella plates modeling in WinSlam. which we were able to take account for. So this is another really large portion of why the city kind of came into compliance here was a lot of new redevelopment and BMP changes along with some internally drained areas. So, I mean, you can see the new development had 21 sites, 74 new BMPs, almost 1,000 acres of affected area, and 569 pounds of TP removed annually, along with 11 sites of redevelopment and then 6 sites for BMP modifications, which came out to a number of more BMPs or pounds per year removed. And then these orange stars are the internally drained areas, which we'll talk about here in a second. So the new and redevelopment, we looked at the internally drained areas. You have to have a 10-year, 24-hour event, cannot leave the site. So if there's any of those sites that didn't have that requirement or didn't meet that requirement, they were just modeled as is in Windslam. But if they did meet that requirement, then they had to meet these 3 following criteria. If they did meet those 3 criteria, then they could be taken credit for internally drained areas. If they didn't, they were excluded from the modeling. And this table kind of shows that some of them met the requirements, some of them didn't, and kind of how everything was included. So alts analysis, as they were in compliance, we didn't have a large alts analysis here, but we did kind of put together something small for them in case they wanted to do kind of optional future work. But it all starts kind of with understanding the DNR rules, the grant writing, the stormwater quality modeling, and then it falls into kind of a water quality trading, a watershed adaptive management, or design and construction of BMPs within the municipality, and all going towards DNR compliance. And the city was helped for a long time by Yahara Winds, which we'll talk about a bit more in a second here. So these were the BMPs that we evaluated for the alts analysis. A number of locations that were open, near park areas, things like that. We kind of provided these for the city in case they wanted to do something in the future. So these are the BMPs that we mentioned. We kind of show pounds that could be removed, cost, their dry to wet ponds, biobasins, wet ponds, expansions of development, BMPs, redevelopment, new development, internal water quality trading. So these are all things that were presented to the city. Yeah, so the water quality trading, do a quick overview of this. If you can trade with ag lands at about $160 a pound for TP. You can do water quality trading clearinghouse to kind of help streamline that process a bit. You can also trade with other MS4s. So for the city, it was the town of Dunn, Pleasant Springs, Rutland, which was not an MS4, or the town of Dunkirk. You can also trade with your wastewater treatment facilities or private point dischargers. So the Yahara Winds is kind of the Dane County area watershed adaptive management. Its goal is to kind of help bridge the TMDL compliance, but the members must achieve 40% TSS and 27% TP reduction for each reach before buy-in. So the city was a member and they were buying in at $48 a pound. And at first they were buying in $11,000 a year. That came down to $8,000 for the 2018 modeling update. And then 2025, they came down to 0 once they were in full compliance. So here's kind of a rough alt analysis table that we put together, shows the different BMPs, key pieces of information, costs, how much treatment it was achieving, and things like that. This kind of helped the city kind of understand each BMP and kind of what they would want to go for in the future. And it shows the 2 different alternatives that are summarized here, the internal water quality trading, which is essentially what they're planning on doing, which brings them into full compliance. But then you also have those BMPs that could be used in the future if they wanted to, or change the hydrodynamic separators if they wanted to. But that was kind of key there, those 2 alternatives. And then kind of the key takeaways and summary is that the MS4 and team deal compliance need not break the bank. Commitment to a water quality program and grants can assist in doing so. A municipal phosphorus reduction credit for leaf management programs analysis brings a low-cost credit for work you are already doing. Internal water quality trading can get you over the compliance hump. Evaluation and maintenance of existing stormwater BMPs is the next wave of compliance. The MPD infiltrometer testing has advantages over double ring for grassland swales and filtration BMPs, and hydrodynamic separator retrofits can be key components of water quality improvements for local water bodies. So at that, open it up to any questions, and yeah, thank you all for your time.
Again, audience, if you have questions, post them in the chat and I'll pass them on to the presenters. Daniel, looking at the pictures that you provided, it looks like some of the ponds kind of look like they were tucked into subdivisions and so on. Is Stoughton a community where the city takes over, or is it a village or city? I'm sorry.
It's a city.
Say, does the city take over privately constructed ponds and then manage them as public ponds after that?
Correct. That's definitely the general approach, especially with the newer developments. Some of the older ones, that really large Paradise Pond was more of a public feature because it was so large. And it was kind of naturalized, or it was natural. It became kind of controlled by the city way long ago. All of the new developments have that approach of the private developer constructs the BMPs, they maintain them for the first 3 years, and then once the warranty period has been met, then they hand them over to the city for kind of further maintenance.
And so the fact that they were public ponds is one of the things that enabled you to tweak them or do upgrades.
Exactly. So that
Whereas if they'd been in private hands, that would have been problematic.
absolutely. Yep.
Yeah.
And that dry to wet pond conversion it's the same thing where it's tucked behind industrial areas, but there was access to it and it was city-owned parcels, so they were able to kind of tweak it how they wanted.
I saw you had $1,000 per pound of TP removal, which sounds like a big number, but based on what I've been seeing, that actually sounds like pretty good.
Yeah, there was a number of alternatives that you can kind of piggyback off on other projects. So reconstructions in the area, new developments in the area, which helped bring down some of those costs quite a bit. So it's kind of to show that you should be planning ahead for these BMPs and kind of pairing them with similar projects or nearby projects in the future, so you can bring down your mobilization, your excavation costs to be something a bit more reasonable because they're paired with a larger project.
Super. Well, I really appreciate both of you taking the time to present today, and it's a really interesting topic, and I'm sure very relevant for a lot of the audience. So thanks very much.
You're welcome. Thank you.
Well, I had hoped to take a short break, but we're slightly behind schedule, so I thought we'd go ahead with Eric Jost, who's our next presenter, and then see where we're at 10 o'clock. So that's my plan for the moment. So Eric is the watershed program manager for the City of Oconomowoc Watershed Protection Plan. Eric guides the city's adaptive management program to reach compliance with phosphorus water quality standards in the Oconomowoc River. The program, which started in 2015, focuses on watershed-wide P reduction strategies, including land management practices, lake improvements, and stream restorations. Eric also helps to coordinate the Farmers for Lake Country producer-led group, which fosters peer-to-peer learning about farming strategies that promote soil health and preserve water quality. Eric's work includes identifying areas of resource concerns, helping farmers and other landowners implement conservation practices, coordinating watershed monitoring efforts, and estimating P load reductions through modeling. So, Eric, I guess you're going to give us a summary of how things have gone after 11 years of adaptive management in Oconomowoc.
Yeah, thank you. Can everybody hear me all right? Is this working?
Yeah, you're good.
Good. Awesome. Well, I appreciate you all listening in. I'm happy to share what this program's been up to for the past few years and maybe give you an insight of what adaptive management is. I'll try to I'll speed it up a little bit to keep that break still an option at the end. But today I'll be providing an update on the phosphorus compliance journey over the last 10 years. These first two slides, I'm just going to give a brief little background on why the program is here, how we got here, what we've accomplished, and what we're going on, where we've been going. So adaptive management essentially exists because of this structure. It's the reason this reason of phosphorus discharge limits at the wastewater treatment plant is set by the Wisconsin DNR. And this resulted in the city of Oconomowoc creating OWPP, OWPP obtains most of its phosphorus reductions by working outside of the watershed, or working outside of the wastewater treatment plant and in the watershed. So adaptive management is our tool that allows us to get out of city limits. Essentially, in 2015, there was two options. It was either spend a lot of money at the wastewater treatment facility for a full plant overhaul so we could meet phosphorus limits at our effluent channel that were coming down through the EPA, or spend a lot less money yearly and be able to work in the entire watershed to achieve the same goal. The key factor about the watershed approach was that the city is surrounded by lakes, and the lake influence is a huge culture in the area. And the wastewater treatment plant is located downstream of all the lakes. So putting those finances at the end of the river system versus being able to apply finances through land management practices and other BMPs upriver is only going to improve lake and water quality for the community. So what we've accomplished, there's a few different areas that we work in. And I will start diving into our reductions on the area that we achieve those. So our annual phosphorus reductions, everything we do has to have a theoretical component of calculated phosphorus reductions. Our ability to work in the watershed is dictated by a DNR permit that has reduction milestones that determine the program's means to continue. These reductions come in two types of sources: non-point and point sources. I'm sure everyone's aware that non-point sources is something that's, it's not a pipe going out into a river, and a point source is like an effluent channel. So in our first permit term, we were required to have a theoretical reduction of about 4,500 pounds of TP, pounds of phosphorus. And the overall success we saw in our first permit term that we actually obtained was about 9,000 pounds. So we were lucky enough to have a few years head start, given our programs coordinator and our city's determination to really stand with this approach before we had our official permit. So that certainly helped. So these are the areas where our reductions occur. Treatment plant improvements like facility optimization. Long-term management projects are things like prairies or erosion control structures that are installed on the landscape and that are either under contract for a lot of years or something that's going to last. Storm sewer improvements like stormwater ponds. I'm sure everyone here is definitely aware of that. And then annual agricultural cost share. It was a short-term project. It's conservation practices that go onto farm fields that are a seasonal thing, like cover crops or removing tillage out of a rotation, something that's going to keep soil in place and reduce erosion. And then we also work within stream improvements, stream restorations, wetland enhancements, invasive species removals, native plantings, and then lake improvements is our last category that we work in. Shoreline stabilization, boating regulations, things like that. For each of these, the DNR sets an expected result they would like to see each permit term, and some of them are requiring more emphasis than others of reductions that need to be achieved. So in 2025, our estimated phosphorus reductions out of the 9,000 pounds that we accumulated, you can see a lot of that is given back to the short-term agricultural cost share. That a lot of that is me going out, working with farmers, convincing and promoting cover crops and other things to be planted that year. There's a little bit of variability on that number every year, depending on rotations in the area and how many farmers I can get on board that year. And then the other next largest area that we have our reductions is long-term management plans, things that once I get 1 year, I don't have to keep going back and achieving them every year. They're on the landscape for a while. Stream and lake improvements, on the other hand, they have a smaller requirement, like I was talking about earlier. This is because the numbers are harder to achieve, and the financial requirement to make some of them is generally the financial requirement generally exceeds the value you get out of your reductions. Stream restorations can be very expensive, and the pounds that you get back aren't necessarily worth going through with it. So for treatment plant improvements, we've primarily focused on phosphorus optimization through tertiary filters and an online orthophosphate analyzer. As shown prior, treatment plant improvements is responsible for about 16% of our reductions. I just wanted to include this note that adaptive management plan doesn't mean that you don't work inside the plant. Yeah, even with adaptive management, facilities are required to improve effluent quality. And we reduced since in the last 10 years, I think our optimization, we've improved at a reduction of approximately 1,400 pounds reduced annually. Municipal storm sewer side of the program, I am not very involved with that. We have another department at the city that picks up all the communication needed between the two programs. But since 2014, we've installed 47 stormwater projects, about 1,300 controlled acres, 700 pounds of phosphorus reduction counted towards the adaptive management compliance. Long-term projects. So actually, that number's a little off. We actually have 61 long-term projects, a little over 1,250 acres controlled by these practices, and about 2,600 pounds of phosphorus reduction every year. So a long-term project is a thing like a buffer strip. It's essentially some aspect of land out of production, out of agricultural production, or into prairie planting, infiltration basins, erosion control structures. This is where we get our longest lasting contributions to water quality, but the contracts can be hard to acquire. Essentially, convincing an agricultural landowner to take 5 or 10 acres out of production that's been helping them support their family can be a daunting task at times, and the contracts can be intimidating to the landowners. But we've had a lot of success in this area, and it's been continued and will be continued as a major focus for the program's long-term stability. Here's an example of a long-term project. This is on a drainage ditch that feeds into a tributary to Lac La Belle. It doesn't always have to be a large area taken out of production. This is only 30 feet wide along a drainage ditch. That, on the upslope side is still planted in corn and beans, but there's a 30 feet of hay grass that the farmer is also allowed to harvest that acts as a filter between any surface runoff and the agricultural field. Here's another long-term project. This one was actually 55 acres of land taken out of conventional production, put into hay and grass. This was a known sediment hotspot converted to perennial hay. The interesting thing about this one is that we knew there was some issues from internal drainage, the tile drainage that was causing problems in the lower Oconomowoc. Our calculation for pounds reduction versus the price tag that this project cost doesn't show necessarily on paper of a pounds reduction, that it doesn't show through calculation that it's an awesome investment. It's close, but it's not perfect. But given our history with the area and knowing what actually happens and actually goes on, it was a no-brainer, and it's proving to be paying off, as there's been a lot less muddy water events coming off of this area. Another one, this is actually like a really good example of what a buffer is. So on the right, you can see what the corn crop, then there's the 30-foot of grass, and then it goes into the riparian area. This was on the lower Oconomowoc River. This was the first project that I was able to install when I came on board with the program. So here's an example of a long-term management project for a lake, a cleared buckthorn peninsula. If anyone is familiar with buckthorn, once buckthorn is established, nothing else really can grow underneath it. So there's a lot of dirt and a lot of soil that's exposed for erosion. We revegetated with a peninsula with grasses and shrubs, some light armoring on some corners that see current. But this is a newer type of land management project that OWPP hasn't done much in the past. We're going to see how it works out for the first couple of years, and then see if our direction, or if it's worth pursuing further in the future for reductions. The nice thing about it is that there was a very involved landowner that wanted to see it happen. So OWPP, the watershed program, had a minority stake in the project. So it wasn't a heavy workload on the program, mostly served as a technical resource and assisted the landowner to commit. So stream improvements, one of my favorite areas of the program. This was our first stream restoration that we were involved with. It was about a quarter of a mile stretch that was it was a straight line at one point, and we gave some more sinuosity to the stream channel and re-meandered it. This was back in 2022. We've also then expanded prairie plantings on the side of it, wetland scrapes, to act as more of a buffer between agriculture. At the time, this was the biggest project that the program's ever had, and from a visual perspective, it's probably still the most impressive. This was a huge undertaking by a partner of ours, Tall Pines Conservancy, and the city of Oconomowoc. This was before my time, but it was truly an incredible project. If you haven't had a chance to check out this site, I'd highly recommend it. It's open for public access, and it is a Class 1 trout stream, and it's flowing through Merton, Wisconsin. While we're on the topic of Mason Creek, each of these blue polygons are of an outlined area or a project that we've implemented on the ground currently that all influence Mason Creek. There are 9 major long-term projects that are all surrounding Mason Creek. It's a lot, but it's still not enough. There's 2 of these contracts that came up for renewal in 2025, and both of them re-enrolled for another 5 to 10 year contract. Cottonwood Creek restoration, our most recent big project. This wrapped up in June of last year. It was a huge undertaking. This was about a half a mile, 2,200 feet. So yeah, short of half a mile, third of a mile. This cost was just shy of $600,000 to complete it. We had big help from a DNR grant and some very generous partners in the area. I think it was the most impressive part of this whole thing that was from starting conversations of this project to completion of construction was just about 16 months. It was a lot to take on at first, and then it was a short time frame, but we were able to push it through. Here's some picture of what the stream looked like before and kind of a diagram of the area of stream flow. One of the biggest parts of this design we wanted to focus on was improved water holding capacity. That's essentially with terms of the grant as well. We needed to help influence stormwater and the amount of water and the open banks that the water is allowed to break out of the bank, and a lot of the amount of water storage that this area can handle is quite impressive. That 8-inch rainfall back in August, it didn't go over the total project bank of it, so it didn't go over into the agricultural field, which the year before it certainly would have. On the left is what it looked like pretty much everywhere. Eroded buckthorn on one side, agriculture on the other side. We cleared the canopy, installed 2 wetland sedimentation basins, tons of log features, integrated floodplain, just an immense amount of water holding capacity. There's some pictures during construction. The log structures help break up water's current, promote sediment to settle out. The upper right picture is like a sedimentation basin. And 3 months later, that's what it looked like. You can see the very wide channel. There's an easy bank for it to break out of. That's not the only stream improvement project we work on. We do a lot of smaller improvement projects as well that primarily focus on invasive species removal and clearing a canopy that's allowing sunlight to get down and promote sedges and shrubs to be growing. And I know I really like the large scale restorations of streams, and they are beautiful, but they do cost hundreds of thousands of dollars, and it's a huge workload requirement. And personally, I can't really do much else when I'm managing a stream construction project. And we have so many miles of streams in the watershed that need a little bit of help. So these are some images of 2 trout stream. Two of these images are of trout streams in the watershed, and it's not really the image that I want representing our trout streams in the Oconomowoc River watershed. We're very, very fortunate to have these trout streams, and over the next few years, I'm expecting the program to give these streams a little bit of long overdue help. In 2025, we started this venture. This is another project on Mason Creek. This was about a half a mile of river shore or river banks that was immensely covered in buckthorn. It was very thick. It was one of those pictures earlier on the slide. And the stream corridor was pretty intact. It had some good sinuosity to it. It had a nice flow, but it was just been some havoc had been put onto it through buckthorn. So we hired some heavy forestry equipment, eliminated the buckthorn, allowed sunlight to get down, grasses to grow. We did put some seed down, but personally, I think the native seed bank took over quite well, and the seed that we put down actually probably wasn't actually necessary. And this is also another spot that is open to public recreation and Class 1 trout stream flowing into North Lake. This is what it looked like 3 months later. Actually, 3 months of growing later. Sorry, the project completed in March, and then this is what it looked like by June. Or July, sorry. And the biggest threat to these projects isn't the capacity to do them, it's the capacity to maintain them. So project partners that are going to sign up for long-term maintenance is probably the biggest limiting factor. If I take care of miles of shoreline, that means miles of shoreline need to be maintained for the next 5 to 10 years diligently. If anyone's familiar with buckthorn, once they cut it, it doesn't go away. It can be relentless. But anyways, after the success of that project, we determined it was going to be worth the investment. We wanted to do more of these projects ourselves, but we needed to be, like I said, on maintenance. We needed a way to help maintain them. And maintaining them with minimal effort was of huge interest. So we're thankful this venture was approved, and we purchased our own equipment and have our eyes on a few miles of stream that need some attention in the next couple of years. We're very, very lucky to have some incredible operators within the City of Oconomowoc DPW and Parks Department that are willing to lend a hand and get out of their normal routine and help me with some stream banks. Work began on Rosenau Creek, our second trout stream in the Oconomowoc River watershed, and this January we did this. This is about a 3rd mile stretch of Rosenau. As I said, Class 1 trout stream in the Oconomowoc River. And yeah, you can probably guess it. It's another spot that's open to public recreation. That's just west of Nature Hill School in the city of Oconomowoc. That's for the first few projects of stream bank. If there's an opportunity for a secondary benefit of public access, that's always going to jump to the top of our list for a project. So short-term projects, like I was saying, cover crops, we generally support 2,000 acres of cover crops every year. 900 is done by drone last fall. Nice thing about getting a drone application of cover crops is that we can get the seed on the ground before the crop is harvested to give the seed a few more weeks to germinate and grow. Get some, but there's so many variables that go into a successful stand germination that it's not going to be a heavy focus to grow that number. We'll support the acres that we can get, but we get better erosion control from vegetation growth off of a conventionally planted cover crop when we're doing that many acres. Another component of the program is not just getting on the ground reductions, but community engagement and community education is also part of our adaptive management plan. This was a project that we completed in 2025. Some of these signs have been installed around the watershed to kind of serve as an educational component to emphasize that all these lakes are part of a community, and that is all because of the Oconomowoc River touches several communities that over 49 miles. And there's an online component to this watershed tour that will have projects and other visual components updated to it every year. We also hold educational opportunities for local agricultural producers. Events through Farmers for Lake Country happen quite often. It gathers a local agricultural community to promote expansion of conservation practices and farming. So adaptive management success is our permit states that by 2032, if we achieve the following of calculated phosphorus reductions, meaning 9,700 pounds, and total treatment plant discharge of holding below 0.5, then that should mean the Oconomowoc River would meet water quality standards, and then that would be success. Well, We've achieved 9,000 pounds of reduction by 2025, and we were required to get 9,700 pounds by the end of 2031. So this is where it gets a little interesting. So an adaptive management program generally lasts 15 years. And at the end of that, the total pounds of reduction that is required, this total reduction is a number set from a huge watershed / water quality equation that if you meet it, you should bring the river into EPA water quality standards. Our original plan projected these reductions shown on the first bar, and fast forward to our actual reductions now that we've done with our first permit term. It looks, looking at the black bar, this number of reductions we were supposed to hit by the end of 2021, we've nearly matched it by the end of our first permit term. And this was the success, or the reason we were able to do this was from the huge lift that my predecessors gave to this program and got this program on its feet. So our treatment plant discharge, this is a graph of going over the years of our improvements we've been able to achieve at the plant. Getting down by 0.5 has been a little difficult, and keeping the plant running smoothly while we're doing that. We've found some challenges, but we've been able to prove that we've been able to keep it down that far. So if we've nearly met our first two goals, then that shows that our river should be meeting water quality standards, or at least getting close to it. We monitor 23 sample sites across the watershed. The red arrow on the left is our point of compliance, which is the end of the river when it meets the Rock River, and the red star is where our treatment plant is located. So our full watershed, looking at results over the past 5 years, this is the median value from all of our sample sites. So you can definitely see a continued improvement from 2021 to 2024. In 2025, we had some spikes, but you can still see that there's been overall improvement. This is at the point of compliance, the spot that really matters. The red bar is the upper confidence limit, the interval limit. That's the number that if we achieve below, you can say with confidence that the river's median is within that interval. This is going back since we started sampling in 2014. That's a little over a decade of data to be looking at. And yeah, as you can see, that there's been some significant improvements within the river, and it looks like we're holding under that confidence interval. So this gets into more confidence intervals, but no matter how it's displayed, you can visually see the reductions in the watershed over each month, and each one of these lines represents a month of water quality sampling. At that point of compliance, we grab a sample twice a month, basically every other week, and all that is charted here. So no matter how it's displayed, it's looking good, and I want to thank you all for paying attention, and thanks to all the partners and the community members who have valued this program. It has led us to achieving such great milestones. We could not have done it without the outstanding support of our friends, neighbors, nonprofits that value water quality. This data does not mean that we're done. Everything we've achieved can be undone quicker than it was made. So keeping OWPP and keeping it on its mission for the next 7 years to keep improving our watershed and solidify these reductions that we've obtained to become permanent is our true goal. So then after 2031 or after adaptive management, our reductions will be there for the community to last. So thank you, everybody.
Great. Again, if you have questions, please put them in the chat. Eric, thanks very much. That's got to be really gratifying, I would think, to see your sample results at your point of compliance showing that you're there. I mean, that's I would guess a lot of adaptive management programs can't do that, or don't get that same kind of result.
A major factor in what we're seeing we got to give a lot of credit to the lakes. There's 17 lakes in the watershed, and all those are gigantic sedimentation basins. So Making a difference with BMPs, I think, is only amplified by our watershed design.
By the way, my department typically in a given year permits a couple of developments in what's now the village of Lac La Belle that have BMPs. And I'm guessing your program is probably not taking credit for those.
Correct.
And but I would think you probably could if you wanted to. And if that's something you're interested in, I could provide you information about how to get data on those BMPs.
I think, I'd certainly like to pursue that conversation. I know that for where we gather pounds reductions, it needs to be stated in our adaptive management plan overall. But that's always something that can be updated to include more or less reduction.
Great. And we got time for one real quick question. Once you meet your compliance, will you be able to use additional reductions in trading?
So adaptive management and trading are two different things, and they're not allowed to commingle. There's a conversation that I've been trying to pursue a little bit on. So program is our focus is TP, but would I be able to trade the TSS that comes along with my BMPs? So that's a conversation that I've been pursuing, but that's going to be a couple year road to see if we're allowed to do that.
Great. Well, I'll reach out to you about that B&B credit that we were just mentioning. And thanks again, Eric. Really appreciate it.
Not a problem. Thank you.
And thanks for getting us back close to the schedule. So
Yeah, I
let's
tried.
take let's take 5 minutes. So let's reconvene at 10:08.
Whoa, hey, bro.
All right, well, it's 10:08 and so let's go ahead with our next speaker, who is Joy Corona. Um, Joy is the Water Resources and Environmental Practice Team Leader at GRAFE. She has more than 29 years of experience in both the public and private sectors, specializing in stormwater modeling, floodplain analysis, municipal flood reduction projects, habitat restoration, best management practice, and sustainable site design, permitting, MS4, and grant support. And Joy is going to be talking about updating communities' waste load allocation calculations for TMDL compliance, permit boundaries, new BMPs, ordinance language, cost-effective compliance efforts. Joy, I worked at Grafe back in the early 90s, and I actually met Grafe, Anhalt, and Schlemer. So,
Back when it was all Graf and Schlemer or gas, right?
yep, exactly. Still have a coffee mug. So thanks for coming. I'll
Of course.
duck out and you'll see me back in about 25 minutes.
All right. You know what? I probably have to share my screen before I start it. I'm following Pete's lead on technical. All right, is it sharing?
It says it started sharing, but hasn't shown up yet. Now we're seeing it, but not in the display mode.
Hmm. Let me see.
It's in like the presenter mode with the notes.
Oh, okay. Let me try again. Apologies. How about now?
It's thinking about it. Right now it's just a black screen.
That's all I did, a black screen for everybody.
Now we're see it, but it's still
It's
in
still
like the presenter
presenter.
mode or the presenter mode.
Interesting. Let's try just to do it this way.
What
And I
happens
even
if you
did the
hit
run through with Kelly to make sure this wouldn't happen. Apologies.
what happens if you hit the slideshow button kind of down in the bottom right? There you go.
All right, good. Was it sharing the full screen? Apologies. All right. So this presentation may be a little bit out of order because we got some really good technical guidance and feedback from Pete and Daniel and Eric, but I think it is still very related. Um, oh, so it isn't actually sharing. Let's try again. Interesting. It is not sharing the way I want it to. I apologize. All right. So what I wanted to do is go over there's going to be a background, which I think, again, is a little redundant, but still good to recall. I zoomed into Waukesha County building. The red indicates that that is an impaired water. Kind of go through the requirements, discuss the overall permit boundary that MS4s are um, completing their computations based on, looking at some exclusions, working toward compliance and ways to make things easier. So again, stepping back for those of you who may not be as versed into it, this all stems back to the Clean Water Act from 1972, which was really a goal to make sure that any impaired waters meet water quality standards. And then you have the Section 303D, which requires states to report impairments biannually to US EPA. So in order for the states to work toward compliance with US EPA, there are total maximum daily loads developed to meet these water quality standards. The DNR Surface Water Data Viewer does allow you to view impaired waters, waters in restoration, and waters that are attaining the standards. They do a great job in, kind of giving you the overall health and status of our waters in the state of Wisconsin. And they are linked to the TMDL reports, and you can get a lot of really in-depth information from the TMDL and reports, including, why it's listed on the 303D list, and some detailed information. This is directly east of the county building in that picture, what it lists regarding the different impairments and data on that location. So, we just want to, I always like to make sure we're thinking about the reason we're spending capital money. And it really goes down back to this Clean Water Act and the goals of meeting water quality standards. So the inherent requirement is that a community with an MS4 permit discharges a pollutant to an impaired water. The permittee is required to implement actions that demonstrate progress toward meeting the TMDL goal. So this is the basis of why or how that evolved. I'm just pulled up an example of some TMD modeling results back from 2020. So a lot of the original TMDL waste load allocation analyses were done in, 2010 to 2016, some updates in 2020 as communities went through the permit process. So I looked at a community with, this was what was submitted to DNR, maybe 2018, and it was accepted by 2020 for a particular community. Each reach shed, and we've looked at those, each community has different reach sheds, and that when it's studied with controls, it has a certain percent of TSS reduction. And, in most cases, we're not meeting the required TSS per the TMDL. So taking a step back, the municipal boundary and reviewing it with respect to, the urban area boundary. So the purple is the urban area boundary based on the US EPA urban area map. So as the way the regulations work, we're really required to be meeting these TMDL goals within the urbanized area boundary or development, directly adjacent to that urban area boundary. So, being cognizant and revisiting the current urban area map with respect to municipal boundaries is a good first step when you're trying to, take a step back and review your overall permitting compliance and computations. And this is an excerpt from Germantown. This purple line is the municipal boundary of the village of Germantown. The gray is where the urbanized area actually extends within the village. So you can see, it is certainly not the full municipal boundary that is part of the urbanized area. In Germantown, they actually also have a rural preservation area, and that protects this area long term to be preserved in a rural sense with low density, single family farmstead type homes. So when I looked at their original permit boundary that was done in their original 2016 work, it was much broader than this gray urbanized area portion. Overlaying it with the sanitary sewer service area. So the village has long-term plans to provide sanitary sewer, and that does go beyond that urbanized area boundary. So in this graphic, you can see in yellow, this is the urbanized area boundary. The hatching here is the sanitary sewer service area. These pinks represent adjacent areas. So there's development that's occurred directly adjacent to the urbanized area boundary. And then there's actually certain areas within the sanitary sewers area that really aren't likely to be developed in the near future. So what I did was work with Pete Wood and others at the DNR to kind of review what is the best permit boundary for use in these waste load allocations. So, you're kind of going back and forth, and we started with, here's the urbanized area boundary, and agreed, let's include these adjacent areas in the analysis, and then let's exclude a couple of these areas that there really is no long-term plan. It's outside of the urbanized area, even though it's in the sanitary sewer service area, there's no imminent plan. So working with the DNR to agree upon what the boundary is for those waste load allocations. And so then you come up with this revised exhibit on, hey, let's only really focus on this portion when we update our analysis, and, not take into account loading from areas that are outside of that. So that significantly reduced the acreage that was analyzed in the waste load allocation model. Also, to kind of look through exclusions and again coordinate that with DNR. So on that exhibit, there were non-village transportation excluded, agricultural areas were excluded, riparian, surface waters, certain woodlands and wetland areas that were to be. So there were exclusions, and again, that is coordinated with the DNR on non-controlled land use and modeled water quality basins, and then some areas that were excluded from the analysis. And reviewing the municipal pond layer. So I think most of the communities now have their pond inventory. There are ponds that are explicitly modeled because there's enough sufficient information. So, here's I think this is from Mequon, of a community where these green ponds were explicitly modeled in their waste load allocation, but the red ponds, although they know that there's ponds here, aren't part of their TMDL credit or waste load allocation analysis, because either there isn't enough information about them, there wasn't a model submitted, this was pre-SWIP, there's a number of various reasons, but really reviewing this pond layer and making sure in the WinSlam that every pond that can be taken credit, or all BMPs, are included in that analysis. And this is a pretty heavily impervious area, so I'm sure with a lot of parking, with surface parking, so adding this in with no control is going to really add up our waste load allocation, even though it is being treated. We just don't get to take credit for it. Again, so this is jumping back to Germantown. So you're kind of holistically putting all this data together, visualizing where the different reach sheds are, graphically, looking at the different types of land uses that are going to make up, in this case, a WinSlam model, areas that are going to be excluded, and again, focusing on, this refined boundary for the MS4. I'm going to keep going because I want to get us back on schedule. So this was the 2022 or 2020 graphic that I put up earlier. And by refining the TMDL analysis, that really reduces the studied acreages. So you can kind of see MN1 is the largest watershed within the community, and it almost went in half when you took out a lot of the areas that we discussed. And then refining it to include additional ponds, updating it based on different current land use. So the old model was done based on previous land use with different some additional developments occurred. But what you can see by just, kind of refining the methodology and making it a little more accurate, we demonstrated that the community is actually achieving an overall 44% compliance, not what was originally estimated to be 33. Now, no in-ground practices were here, so spending time to refine the analysis, it's going to reduce the capital cost of compliance. So there is still capital cost, and part of our 5-year next MS4 permit is to identify what measures the community is actually going to implement to reach the goal, but spending some time and money to, make this first analysis as accurate as possible will help identify, how much capital money do I really need to spend, and should help you identify locations, where you get the best bang for your buck a little more accurately. Um, you know, and this is a little different than what Daniel had indicated, but some in communities where there's smaller ponds with, small watersheds, converting a single pond from a dry basin to a wet pond, may only move the needle less than a 0.5%. Um, Granted, when you have a pond that receives 180 acres, that's a lot more bang for your buck. But these converting small ponds in small residential areas may not achieve what you want to achieve. So the tips and tricks, again, looking at those exclusions, reviewing the pond layer. Another piece that'll make it easier, so every 5 years we're updating our permit submittal with the DNR. If you start requiring digital wind slams from your applicants when they come in for a permit, it'll make it easier to continue to update your model. So, there's a lot of time and effort creating that. So if you start requiring WinSlam and then when it's time to re-up and update our progress, that makes life a lot easier. Also, reviewing ordinance language. Some ponds are excluded from analysis because they lack maintenance plans and access agreements. So again, although this doesn't move the actual dial, it does make us have a more accurate model in the first place if we are able to take credit for as many of the ponds as possible in our analysis. And then this effective compliance efforts, again, I think, Eric and Pete and Daniel have hit on a number of ways, but, the accurate assessment really refines the overall percentage. The long-term maintenance plans and unmodeled ponds does help us identify how close we are to achieving the required TMDLs a little more accurately. And looking at capital projects, how are we spending those capital dollars to try to meet that goal? Is a single BMP enhancement effective? Or maybe adding BMPs in heavily loaded, untreated areas are, getting a much better bang for your buck. Adding grass swales and filter strips in untreated areas. So, in my experience, looking at adding TSS reduction features in areas that aren't treated gets a much bigger bang for your buck than, enhancing an area that has some treatment. It's just not functioning as good as it could be. Improving the community's street and catch basin cleaning. And as Pete just said, soil mitigation may be a really good way to try to start meeting compliance on these untreated areas. So what is really impactful toward achieving the overall goal? So this is how I feel. We did have a break beforehand, but we can still ask questions. And we should be just about back on track.
Yeah, you're doing great. Thank you. Yeah, when you talked about refining the boundaries, I was a little surprised because I thought that basically you went by census tracts and it was fairly rigid, but you're saying that there's actually some negotiability in there.
Well, a community that's fully urbanized, you're right that there isn't a lot of room for negotiation. It's those communities that straddle the urbanized area boundary and, in Waukesha County and, as you go a little further out, you can see from that purple map that not everywhere within a community may be part of that urbanized area. So in that case, there is opportunities to refine that boundary. And I do think that that is a piece that I saw quite a bit when looking at a number of waste load allocations for communities, that I think the assumption in the beginning when we first did them was this is the strict, we have to do everything for our corporate limit, and didn't go back and look compared to that urbanized area layer.
Mhm.
And Pete, you're probably still on, so you can correct me if I'm wrong.
Um, yeah, I imagine, obviously doing all that analysis costs something, but I would think relatively speaking, the cost of doing what you did is tens of thousands of dollars, whereas if you have instead to build a basin, you're talking hundreds of thousands of dollars, if not more. So,
Correct, correct. So, there was in one of the communities, some pond retrofit proposed, and it was about $180,000, and it moved the dial, like that, less than a 0.5%, as opposed to spending, a couple $20,000 on refined analysis and realizing actually we're 10% closer than we thought toward meeting the overall goal. So, and it, helps you really get a better handle on where each reach shed is at. So
yeah.
that is kind of what the intent of this presentation was, to kind of advocate for um, wise expenditure of capital dollars to reach that goal, like you said.
Right. Plus, I think, what I'm guessing that a lot of the kind of work you're doing is paid for through planning grants, which are, out there and accessible and may actually be easier to obtain than, term grants for actually doing hard practices, essentially.
Correct. So the only thing that I will caution, as part of if you're, proposing to do this as part of your next 5 year, the DNR will also want to see progress toward improving the actual on the ground. So just doing this alone does help and can be part of your next 5 year program, but they also want to understand that you're doing some boots on the ground effort to also bridge that gap, because we know just a refined analysis isn't going to hit the TSS, but it's going to get you closer.
Audience question: do you provide guidance on how you want designers to prepare the individual wind slam models for private development to make it easier to integrate with the community-wide modeling?
So my experience would be that if they actually provide the wind slam, it's easy to accommodate. What we've done on some communities is create a folder to the DNR of all the wind slam and then include that in the pollutant load reduction table. And so you're basically sharing a folder of all the submitted wind slams, and that's sufficient for the DNR. They don't have to be integrated into a single community-wide wind slam.
Right. Well, Joy, thank you very much for taking the time to participate. Really appreciate it.
You're very welcome. Thanks.
Okay. So next up, we have Eric Hetler, who is the water quality modeler at the Wisconsin Department of Natural Resources, where he has worked for the past 7 years. His work supports studies that identify pollutant reductions needed to improve water quality and to meet clean water targets in Wisconsin's rivers and lakes. Eric has served as the lead modeler and co-project manager for the recent Fox Illinois River Basin TMDL. And that is exactly what Eric is going to be talking about, what the current TMDL status is, and I believe he may have some news about draft allocations, which is very interesting for me personally. So Eric, welcome, and I am going to turn off my video and turn it back on in 25 minutes.
All right. Well, thank you so much for having me. So for the last few years, I've been kind of leading the efforts for the Fox Illinois River Basin TMDL. My colleague, Kevin Kirsch, who's also on the line, he's our statewide TMDL coordinator. And a nice thing about having him here is he's been instrumental in helping keep this project moving. And he's also been a leading force behind developing the guidance and policy around implementing TMDLs in the context of permanent MS4s. So like I said, I'll be handling the presentation, but Kevin will be available to help address any questions you may have. Today, I'll be talking about the TMDL project. I have updates on the project, including the draft allocations. And then I also want to spend some time talking about really what everyone else has been talking about, how the results of the TMDL are actually incorporated into the permanent MS4 implementation. So thank you to all the previous presenters for really helping set the stage for that second half of this presentation. So it sounds like a lot of you are very familiar with TMDLs, but before I dive into this specific project, I do want to provide just a very quick reminder about what a TMDL is and why one's being developed. And then once I go through this introduction, I'll talk about the TMDL development process, the allocations for the Fox Illinois River TMDL, and the implementation of the allocations in the permitted for permitted TMDL, for permitted MS4s. So what is a TMDL? Basic definition, a TMDL is the maximum amount of a specific pollutant that a water body can receive while still meeting water quality standards. And the first component of this is the load allocation, which refers to all the loads from sources other than point sources. So these are your non-permitted urban areas, your agricultural areas. The second component is a waste load allocation, which refers to loads from permitted point sources, such as municipal treatment outfalls or permanent MS4s. And then the third component we incorporate into the TMDLs is this margin of safety. This is applied to account for the fact that there are always uncertainties around these models. So the models have some uncertainty. The data collection process has a bit of uncertainty associated with it. So we incorporate this margin of safety to really address those concerns. And then the results of this calculation are used to allocate loads to each of these different sources in a watershed. Now, why do we use TMDLs to address water quality impairments? It was alluded to earlier by Joy, but the requirements for the development and implementation of TMDLs stems from the Clean Water Act. And the Clean Water Act is a federal law that was established in 1972 and amended in 1977. And this created the goal of fishable and swimmable waters for waters throughout the country. And Wisconsin is delegated by the EPA to implement components of the Clean Water Act. So a good example of this is the National Pollutant Discharge Elimination System. That is mirrored in Wisconsin by our WIPDES program. So Wisconsin is delegated by the EPA to really develop and implement these TMDLs. So for this specific project, where is it located? This project incorporates a bunch of watersheds in the southeastern part of the state. And although the project name is the Fox Illinois River Basin TMDL, the project area contains 7 distinct watersheds within southeastern Wisconsin. And the largest of these basins is the Fox River Basin, which is shown in the light blue on this map. And the second largest of these basins is the Des Plaines River Basin, which is shown in green here. So this project, again, called Fox Illinois River TMDL, but it does incorporate the Des Plaines as well. And then other smaller basins within the project area include the headwaters of Nipperson Creek, the North Branch of Nipperson Creek, Channel Lake, and North Mill Creek, and it also includes North Lake. And this TMDL is developed for both total phosphorus and total suspended solids. This TMDL is required because the project area contains impairments for both these pollutants. And within this basin, there are 11 named streams and rivers and 12 lakes that are listed as impaired for total phosphorus on the 303D list. And in addition to these, major water bodies, as you can see in this map, impaired for TP include the Fox River, Sugar Creek, the White River, and the Des Plaines River. And then in addition to these TP impairments, there are also 7 named streams and rivers and 1 impoundment listed as impaired for TSS. And this map on the right shows where those TSS impairments are located. And now that we have some context about TMDLs more generally, I want to just briefly go through the process we use to develop TMDLs. So if you've been on previous TMDL calls that we've had, this will look very familiar. And the development for this specific TMDL follows the exact same process that we've used for previous TMDLs. So the first step in this process is the collection of monitoring data. And monitoring data for the Fox Illinois project was completed from 2020 through 2022. It involved 2 components. We were monitoring for chemistry. We're also monitoring for flows using stage as kind of a proxy for that. And we collected data at 13 different sites within this basin. And then we used existing data to also supplement the data that were collected specifically for this project. And the next step of the TMDL development process is conceptualization. This is a step where we really try to understand what is happening in the watershed. So to do this, we use a variety of data sources. So we have detailed surveys from the county conservationists, which are critical for the agricultural side of things. And we use these data sources to characterize land use and land management, climate, soils, topography, slope, and hydrography, which is just how all the rivers and streams and lakes are connected. And then once we have monitoring data and the detailed information about the watershed, we move on to the modeling phase of the project. And this is probably the most technical and time-intensive component of the TMDL. So I'll just give a quick overview of what that process looks like. So a watershed model is developed to estimate flows and loads throughout the watershed, especially in places where we don't have sufficient monitoring data. This is a pretty large project area. I mentioned we have monitoring data at 13 sites. We need this watershed model to characterize what the pollutant loads are throughout the entire project area. And for this project, we developed the watershed model using SWAT Plus, which is just the most recent version of the Soil and Water Assessment Tool, or SWAT. SWAT is a model that we've used for a lot of our previous TMDLs, so it streamlines pretty well into what we've already done before. And this flowchart just shows a general process for developing the watershed model. We first use the data from the conceptualization process to set up the model in SWAT Plus. Once the model is set up in SWAT Plus, we then use the flow and water chemistry data to calibrate and validate the model. And then once the model is sufficiently calibrated, we're able to use it to calculate baseline loads. And these baseline loads lead us to the next step in the process, which is allocations. And the allocation process involves using the data from the watershed model to assign specific allocations, essentially load per year, to each of the different sources across the project area. I'll provide a lot more information on the allocation process that we used for this project. Again, it's the same as the allocation process we've used for previous TMDLs. And then once we have allocations, we truly have a framework that we can use for implementation. And implementation for these TMDLs really focuses on two primary sources. So again, we have the non-point sources that are not permitted and the permitted, or the point sources that are permitted. The non-permitted non-point sources are primarily agricultural lands. It also includes non-permitted urban. It's important to acknowledge this TMDL, any TMDL, does not create new rules or regulations. So from the agricultural standpoint, we are somewhat limited in using the tools that are already available within existing code. To do this, we develop edge of field targets that allow us to essentially determine the extent and the location of practices that need to be implemented to reach these TMDL goals. And we also are able to use the watershed model to really prioritize watersheds that need some additional work. Implementation for permitted point sources, including permitted MS4s, is a little bit different. For these sources, the allocations from the TMDL are actually incorporated into existing permits. And I'll provide more information on what this looks like from a permitted MS4 standpoint later in this presentation, but I think you've gotten a pretty good overview of what that looks like through these previous presentations. So right now, we are currently in the allocations process. We just wrapped up the draft allocations. So that's what I'll be talking about here. And before going through the specifics of the allocations, I just want to provide a quick reminder on why we actually need to develop these allocations. So in some cases, the baseline load entering a watershed exceeds the total maximum daily load, which results in a concentration that is above the water body's water quality criterion. In these situations, the amount of a pollutant entering the water body needs to be reduced, so the total maximum daily load is met. When the TMDL is met, the receiving water body should meet its water quality criterion, which I think in the case of the Oconomowoc River, you saw that implementing these practices, you can see a pretty direct response within the watershed or within the water body. So that was really nice to see. And as I mentioned, the allocations process really starts with determining the baseline loads. And baseline loads are comprised of four main components. We have our natural background loads, our agricultural and non-permitted urban loads, general permit loads, and permitted MS4 and permitted wastewater loads. And then we calculate this allowable load, which is your total maximum daily load. It's comprised of the same components as the baseline loads, but the loads for the controllable loads are adjusted to ensure the allowable load is not exceeded. So when I say controllable loads, I'm talking about agricultural and non-permitted urban, permitted wastewater and MS4 loads. And the reductions are not applied to the natural background loads because these sources are considered non-controllable. We're obviously not going to be implementing practices on naturally forested lands, although you saw through that presentation at Conmawalk that there is some ability to directly target these, what we would call natural lands, which are covered in invasive buckthorns. But regardless, we aren't applying specific reductions to these natural lands. The allocations also include a reserve capacity. This is just a load that is set aside to accommodate any new or expanding discharges in the future. And the baseline load is compared to the allowable load, and that gives us this required reduction in order to meet the TMDL. So let's talk about what this looks like with the Fox, Illinois TMDL specifically. For total phosphorus, the required reductions in the project area range from 0 to 92%. The majority of basins in the Fox River watershed are assigned an 85% reduction. The basins in the upstream portion of the Des Plaines River are assigned a 77% reduction. And the basins for the downstream portion of the Des Plaines River are looking at about a 37% reduction. If you're familiar with the Fox River, you may know that especially in the lower portion, the current water quality criteria is actually pretty close to its criteria, or the water quality in the river is pretty close to its criterion of 100 micrograms per liter. So you might be thinking, like, why are these reductions so high? Well, the Fox River is unique in that it discharges to Grass Lake in Illinois, which is just downstream of the Wisconsin border. And Grass Lake is the upstreammost lake in the fairly complex chain lake systems in Illinois. When you look at the contributing watersheds to Grass Lake, you find that approximately 96% of the area upstream of Grass Lake is within Wisconsin. And EPA, they have recognized that pollution does not stop at the border, and upstream states are required to ensure that the loads coming from their states are not resulting in water quality impairments in downstream states. And after reviewing EPA guidance, reviewing a few Supreme Court cases, and having direct discussions with EPA, it was determined that Wisconsin is required to consider the water quality in Grass Lake when developing this TMDL. And the lower portion of the Fox River has criteria of 0.1 milligrams per liter, like I mentioned. Grass Lake has a much more restrictive criteria of 0.05 milligrams per liter. So even though we may be getting close to meeting criteria in the lower portion of the Fox River, we still need to make some major reductions to meet the in-lake criteria for Grass Lake. And we also have calculated reductions to meet the TSS criteria for each reach in Wisconsin. And this is important to note that Wisconsin doesn't have a numeric water quality criteria for TSS, but we do have a narrative criteria. The main component of the narrative criteria for the TSS standard is the standard of no objectionable deposits. While that's important, the narrative criteria is not really directly translatable to the TMDL. However, we have used a process to translate the narrative criteria into a numeric target of 12 milligrams per liter. And the numeric target was established using the same protocols that were used to develop the numeric TP criteria. And TSS reductions for the project area range from about 0 to 95%. Most subbasins in the Fox River watershed are assigned roughly a 35% reduction. The upstream portions of the Des Plaines are looking at about a 60% reduction, and the downstream portion of the Des Plaines is about 20%. One important note about TSS, Illinois does not have a TSS criteria for lakes. So as a result, we did not have to account for Grass Lake when we developed this TMDL for TSS. And I just gave a really quick overview of the allocation process and allocations. I'm sure you still have some questions. Luckily, we are hosting a webinar on April 8th at 1:30 p.m. to formally present the draft allocations. The webinar will also walk through the draft TMDL report, which will include the entirety of the TMDL project, from monitoring all the way through the allocations. And the draft TMDL report will be posted sometime before the webinar. If you're interested in attending this webinar, you can find the link to the registration by visiting the project website. The easiest way to find the website is just going to DNR's website, and searching for Fox, Illinois TMDL, and that'll provide a link directly to our project website. So this morning, you've seen a lot about percent reductions required within MS4 basins. I want to step back and give a bit more context about how those numbers relate to the TMDL and how they're calculated. So as I mentioned, permitted MS4s fall under the waste load allocation portion of the TMDL allocations. And in the final report that we submit to EPA, and you'll see this when we release the draft of the TMDL report, every source in each TMDL subbasin will be assigned a load allocation or a waste load allocation. And again, this is the maximum amount of load from each source to meet water quality criteria. And this table just shows a few rows from the TMDL table for total phosphorus that summarizes the allocations. Specific numbers not important right now. I just want to show kind of the structure of what this looks like. And the sources that are assigned specific allocations include natural background loads, agriculture, non-permitted urban, general permits, permitted MS4s, individual permits, and then again, we have this reserve capacity that's set aside. And as you can see, permitted MS4s are included in the waste load allocation portion of the TMDL, and the MS4s are in each subbasin are assigned a specific allocation. So this is an example of what the TMDL table would look like specifically for permitted MS4s. The numbers here represent the annual maximum pounds of phosphorus delivered from areas defined as MS4s. And these numbers are calculated from the SWAT plus watershed model. So the real question is, what does this mean? And what are permitted MS4s supposed to do with these numbers that are in the allocation table? Well, as I mentioned, the MS4s, the waste load allocations are generated from loads developed in the SWAT plus watershed model. And this presents a real challenge for implementation. As Dan mentioned in his talk, load from the permitted MS4s is typically characterized using urban stormwater models such as WindSlam and P8. Loads from the SWAT plus model and the urban watershed models are not really directly comparable. So there is this model mismatch. The SWAT plus model is developed at a watershed scale for large subbasins, whereas the urban models are much more site specific. The SWAT model is primarily focused on agricultural runoff and groundwater, whereas these urban models are specifically focused on urban runoff. The SWAT model is developed using a daily time step, whereas the urban models require sub-hourly time steps to address the flashiness associated with the different rain events. And finally, this is a really important one. The SWAT Plus model does have the ability to incorporate BMPs, but the BMPs are fairly limited and very generalized. As you heard for the other presentations, WindSlam and other urban runoff models have a much more detailed approach to assessing the performance of BMPs. So how do we reconcile these differences between the allocations derived from the watershed model and the reality of how urban watersheds are characterized in practice? And details about the implementation process appear in a few distinct locations. There's NR 216, there's stormwater permits, and then there's this MS4 guidance for MS4 permits. And you can consult each of these resources for details, but I'll provide just a very high-level overview of some of the core concepts from this guidance. So as mentioned, there is a mismatch between the SWAT plus watershed model and the urban stormwater model. And to overcome this mismatch between the waste load allocations, the waste load allocations in the TMDL are really expressed as a percent reduction. So once percent reductions are calculated, they can be applied to the urban stormwater models that permitted MS4s have already developed. And to explain this process, I'll go through a really quick example. This is a subbasin from the actual Fox Illinois River TMDL. And this figure shows TMDL subbasin 3, which is the northern portion of the project area. And the stream that's unnamed is currently impaired for total phosphorus. There are 4 MS4s that intersect with this subbasin. There's the village of Sussex, village of Lisbon, city of Pewaukee, and the village of Menominee Falls. So the first step in expressing waste load allocations as percent reductions is identifying the baseline load from the TMDL. And then you identify the downstream allocation. And I'll provide quick definition of local versus downstream allocations in a few slides. For now, I just want to focus on these numbers and how the percent reductions are calculated. So percent reduction is just calculated by subtracting the allocation from the baseline and then dividing by that difference by the baseline. And for subbasin 3, this results in a percent reduction to meet local allocations of 47% and a percent reduction to meet downstream allocations of 85%. And this table kind of summarizes that percent reduction required from the TMDL basin load, but there is a caveat. So the baseline loads that we use for developing the TMDL are calculated assuming the permitted MS4s are already meeting their NR 151 obligations. So to calculate a usable, implementable percent reduction for the MS4s, there's one additional step that's required. And this involves taking the NR 151 reductions of 20% for TSS from the no controls condition, which corresponds to a 15% reduction from no controls for total phosphorus. And the baseline loads used in the TMDL are adjusted, so the model baseline TSS from the permanent MS4s is reduced by 20%. Modeled baseline TP load from the permanent MS4s is reduced by 15%. And to translate the reductions to the TMDL reductions to a final reduction from no controls, we just use these two calculations. And what this means for subbasin 3 is your percent reduction from no controls is expressed as 55% for the local allocation and 87% for the downstream allocation. So I alluded to the local and downstream controls, but what exactly does that mean? I'll spend the final portion of this presentation just going through the definition of local and downstream reductions and their importance. So local reductions relate to the local water bodies criteria and allowable load. The reach in subbasin 3 is impaired for TP, and that means some level of reduction is required within subbasin 3 to ensure the reach meets its water quality criteria. The reduction required for it to meet its local criteria is referred to as this local reduction. Downstream reductions are more global. Even if the local reach meets its water quality criteria, it may still be contributing to an impairment of a downstream water body. In the case of this TMDL in the Fox River Basin, that downstream impaired water body is Grass Lake. So to ensure Grass Lake meets its criteria, additional reductions from subbasin 3 are required. And as you saw in previous slides, the downstream reduction is higher than the local reduction. So the ultimate reduction that must occur in subbasin 3 is really controlled by this downstream reductions. So why do the local reductions even matter? You heard a little bit about trading and adaptive management already, and this is exactly why we need to evaluate local versus downstream reductions. So if an MS4 or a point sources engages in a trade to offset their waste load allocations, geography here really matters. Trading to address local water quality must occur in the same subbasin or in an upstream subbasin of the reach. However, if the point sources engages in a trade to address downstream water quality, that trade can occur anywhere located upstream of the downstream controlling water body. So in this case, in the Fox River Basin, theoretically, you could implement a practice anywhere within the basin to address downstream water quality because Grass Lake is controlling. So here's a quick example of what that means. If practice A is implemented within subbasin 3, reductions of that practice can be applied to offset both the local reduction and the downstream reductions. If practice B is implemented outside of subbasin 3, the reductions generated from that practice can only be applied to offset the required reductions needed for Grass Lake. So let's use just some hypothetical numbers. Let's say the baseline load for the city of Pewaukee is 10 pounds. To meet local water quality criteria, at least 5 pounds of reductions are required. To meet Grass Lake, 8.5% reductions are required. If practice A generates 8.5 pounds of usable credits, that entire amount can be applied to the 5 pounds for the local reduction and the 8.5 pounds for downstream reduction. So local and downstream required reductions are both being met with that practice. If practice B generates 8.5 pounds of usable credits, only 3.5 pounds of that could be used to offset the required reductions. And the reason for that 3.5 pounds is you subtract the required local reduction of 5 pounds by 8.5 pounds. So in order to meet the obligations, an additional 5 pounds would still need to be generated somewhere within subbasin 3. If that doesn't happen, the reach in subbasin 3 would still not be meeting its local water quality criterion. So that's a lot. As I mentioned, we have documentation of this process in NR 216, stormwater permits, and the guidance document. So real quick to close, just want to discuss final next steps for this project. There's this webinar on April 8th that is going to be occurring at 1:30. After that webinar, we'll open it up for a public input period through probably about May 8th. Once we get comments back from that, we'll work to address all of those comments. And once the TMDL is finalized, we will be public noticing the TMDL in early to midsummer probably of this year. And then after that public notice, there is a formal 30-day comment period. And then once we go through that process, we'll make any adjustments to the final TMDL report that are required. Then we'll submit it to EPA. And then EPA has 30 days to make a determination on whether or not they approve the TMDL. So realistically, we're looking at probably a late fall, early winter TMDL approval if everything goes well. So again, here's information about the scheduled webinar that's happening on April 8th. When you go to our website, you will also see a link to our Gov Delivery email list. If you're interested in seeing project updates, you can subscribe to that list, and anytime we send out a notification, you'll receive an email from us. And with that, we can open it up to some quick questions. Again, as I mentioned, Kevin Kirsch is also on the line, so he'll be able to address any of the bigger picture questions you may have.
Yeah, audience, please put any questions you have in the chat. I was jotting numbers down while you were flashing them on the screen. Did I see 85% TP reduction for the Fox?
That's correct, yes.
Yeah, that's higher than any number I remember for the Rock or Milwaukee TMDLs.
Yes, it is higher than most of those. It is pretty consistent with what we've seen in some of the other parts of the state where we do have these downstream controlling water bodies. So for like the Upper Fox Wolf TMDL, Lake Winnebago is controlling a lot of that. And that's where we see a lot of these really big reductions of up to 85%. So it is consistent with what we've seen in previous TMDLs. It's just, yeah, the Rock and the Milwaukee didn't have this downstream controlling water body situation.
And the other number I wrote down was 35% TSS for the Fox. And I know you showed a map showing, a wide range, but that was I guess, kind of your ballpark average.
Yep.
That's, the difference between that and the TP number was also, a 50% difference. And my recollection from the other TMDLs was, the numbers were certainly not the same, but they tended to sort of move in parallel in most reach sheds. So I was a little surprised at that as well.
Mm-hmm. Yeah, that's a really good observation. And again, that comes down to the fact that for TSS, we are not having to address Grass Lake because it doesn't have a TSS criteria. As you know, I mean, if you're meeting an 85% reduction for TP, these TSS reductions are going to be a non-issue.
Right. Yeah, that's for sure. So on the schedule you gave, at what point in there would the reach shed geometry or polygons or whatever the terminology for it is be published?
So those are already published, and also on the website we have a bunch of recorded webinars that we've conducted throughout this process, and that would be, I think, in the conceptualization webinar. But that goes through kind of how we determined where to draw these subbasin boundaries, and there is a shapefile on the website that shows where these subbasin boundaries are located.
Okay, so for the polygons, go to the TMDL website and there's a place there to download them?
Yep.
Okay. And this is maybe kind of an off-the-wall question, but based on other presentations I've seen, bed load and stream bank erosion can be pretty large contributors to, pollutant loading to uh, streams. And, I'm pretty sure that neither of those is included in the SWOT or other modeling that was done as part of this process. And I know that that would be very difficult to do, but was that ever discussed at some point, or was it just not possible?
Yeah, there are some routines within SWOT that we do use to kind of characterize sediment loss and sediment deposition within stream reaches. It doesn't really get at erosion directly. But yeah, that is one of the big challenges, is trying to characterize that is challenging, but that is somewhat addressed through the calibration validation process.
Mhm.
Really, a lot of that would kind of be distributed throughout the sub-basins as kind of a proxy of the stream bank erosions.
Well, Eric, I really appreciate your taking the time to talk about something that's going to keep us really busy for the next 10 or 20 years.
Yes, yes, indeed. And yeah, any questions y'all have about this project specifically or TMDLs more generally, feel free to reach out to me directly. My email address is at the bottom of the screen here.
Great. Thank you very much.
All right, thank you.
Well, next up is me. Let's see here. So, I'm going to be presenting on the county's stream bank stabilization for water quality trading, which we did in the last year. And my co-presenter is going to be Nick Hayden, who works at EOR, which is Emmons, is it Olivier or Olivier and Associates, which used to be Montgomery Associates at one time. Nick has 24 years of experience in water resources, beginning his career as a GIS and hydrology specialist in the Western US before transitioning to water resources engineering. He applies H&H modeling, GIS and CAD tools, and a comprehensive understanding of water systems to analyze, design, and clearly communicate project solutions. And just out of curiosity, Nick, where are you?
I am in Eau Claire.
Oh, okay.
I am not in northern Spain at the moment.
All right. Well, let me see if I can get our PowerPoint up here. Let's see. Is anybody seeing it?
It doesn't look like you're sharing yet, Leif.
Oh, I need to hit the share button. Okay. And are you seeing it full screen now?
I think it's still loading. It is showing that you're sharing, but we're still just seeing the black screen. There we go. Now we see it.
Great. Okay. So, the county has its own MS4 permit, and it requires us to comply with, among many other things, the Milwaukee River TMDL. And the county TMDL, I'm sorry, the county MS4 in the Milwaukee River TMDL is essentially our highway system in that part of the county, which is shown in the Milwaukee River TMDL is just the upper right, upper northeast corner of Waukesha County. Our MS4 is the highways. It's a mix of 2-lane and 4-lane, some rural cross section, and curb and gutter. And everything in between those green lines that represent the highway is municipal MS4. County doesn't own any other property in the watershed. We don't have any parks. We don't have any DPW shops or anything like that. And this part of the TMDL comprises 8 separate reach sheds, and we have MS4 in 7 of them. And we had a treatment shortfall in all 7 of those reach sheds. So we had to figure out what to do because the county MS4 is these highways. We don't have any place really to put basins. We were able to sneak in a basin in one piece of right of way where we had a little bit of extra room to work. But for the most part, we were very constrained on space. So building basins for the most part was not an option. So we looked at street sweeping, but in a couple of watersheds, we were able to get where we needed to go by doing some additional street sweeping. But street sweeping is pretty limited in effectiveness, and it's also fairly expensive. So another option that we looked at was water quality trading. And our first thought was to look upstream, look for some agricultural land and work out a deal with a farmer. But of the of the 7 reach sheds, in 4 of them, we were able to either sneak in a basin or do some street sweeping and get in compliance that way. In the other 3 reach sheds, we had to find something else to do. And in two of the reach sheds, there was no agricultural land available, and there was nothing upstream either. Essentially, each reach shed was at the top of the watershed. In the other reach shed, there was some agricultural land. It was all in Washington County across the border. We looked at roughly 60 candidate properties. We're not able to find, I'm sorry, we were able to find one property that seemed like it was a candidate, and we negotiated with that farmer and got to the point of signing an agreement, and he sold the property. So that fell through. So dug back into the water quality trading guidance, looked at Appendix F, which talks about stream bank stabilization. And initially, I talked to some peers about this, and they said, no, you can't do that because the MS4 modeling, I'm sorry, the TMDL modeling assumes that all the streams are already stabilized. But when I looked at the guidance, it actually says that all the conveyances are stabilized, and we weren't looking at stabilizing conveyances, we were looking at stabilizing the streams themselves. So talked to the DNR, and they said, yes, you could actually do this. So I looked for some examples of trading. And every example that I could find was for wastewater treatment plants. And mostly they were trading with agriculture. So, when I dug into it further, I was able to find a few stream banks trades for 3 different communities, but none of them were for MS4s. So the next step was to find some instances of stream where we could do some stabilization. And basically in the TMDL area, I looked at basically every inch of the main streams to find instances where there was measurable bank regression. And did that using initially air photos. We have pretty good quality air photos going back to the early 2000s. So I was able to do a comparison over 15 to 20 years to look for areas where the bank was visibly regressing. The other thing I did was I focused on municipally owned land that was accessible. The reason for avoiding private land was difficulties in working with private landowners, the possibility that they might want some sort of compensation, difficulties in getting access, and also private landowners generally don't have an incentive to cooperate, whereas the municipalities potentially did. So produce some cost estimates and some load reductions, and things were looking good. The only thing was we had 0 funding. And part of the reason for that is that counties are prohibited by statute from forming utility districts. So we don't have an annual funding source of that kind. We had applied for some grants to do some different projects, but had been unsuccessful. But then COVID happened, and after a year or so into COVID, the federal government produced the ARPA program, which was aimed at infrastructure improvements, including water infrastructure, and that included stormwater and the like. So we were able to get some funding through that program. And at the same time, we were able to get some funding for a new street sweeper as well. So having some locations and some funding, we reached out to 4 potential municipal partners and said, hey, we'd like to do these stream bank projects on your land. What we would do is if you'll give us the access, what we'll do is pay for the work and we will manage it and we'll give you half of the load reduction. They all agreed. So we hired a design consultant, EOR, and proceeded to do soil sampling and some preliminary field work, such as taking photos and making physical measurements of banks. So I will turn it over to Nick at this point, who did the design work.
Thanks, Leif. Yeah, at EOR, we do quite a bit of stream work, and a lot of our sites are longer and more rural type sites, like those seen on the right here. We do a lot of work in the southeastern Minnesota along trout stream, along fisheries easements. And I would say that urban streams are somewhat of a different animal, especially that they have a lot of constraints for designs. And I imagine several of you on the call work along urban stream corridors, and you're typically dealing with Zone AE floodplains and tight property boundaries along the riparian corridor. There are often utilities. It seems like sanitary sewer is often right there at the site or crossing or totally exposed from where the stream has incised and dug down over time. Access can be kind of challenging with multiple landowners and properties along the corridor. Certainly multiple levels of permitting. And then, typically we're dealing with pretty low base flows and shallow stream levels, and then, but then big floods as well. So a bit of a different setting than some of our stream practices, but we kind of took the approach that a lot of the practices that we use in our other projects are still applicable in terms of the design techniques. So we were looking at using some of the same concepts in the design, such as native vegetation. Wherever we could, we were putting in floodplain benching and sort of expanding that cross section that the channel would use when flows popped up to take pressure off of the main channel and off the slopes and the banks that were experiencing the erosion. Trying to reincorporate large wood whenever it was available on site into the design. And then we ended up using a lot of boulder toe, which I'll show a little bit more of, just to stabilize these areas at the toe of the slopes that were failing. And the design kind of needed to meet that water quality trading criteria. So we did need to demonstrate that these were going to stabilize these sites to meet the trading plan. And to satisfy the property owners that, have them be comfortable with these designs. Needed to meet the construction budget across several sites, including a couple of other BMPs that we were designing at the same time. There were lots of permits. I think there were like 24 permits across these 4 stream banks and 2 other sites. And then we also wanted to, where we could, incorporate habitat features, which a lot of these goals were overlapping in that the permits certainly encouraged, or in some cases required, some of this habitat inclusion on some of these features. So lots of objectives, but I think they kind of all work together. So Leif, you can go on to the next slide. So we started off with that site visit. We went out with Leif and looked at some of the worst areas along several of these sites. We were confirming sort of which areas we were going to apply these stabilizations, and especially looking at kind of where we would tie in to better stream bank areas and identifying red flags or which types of techniques might be appropriate in certain areas. And I will show some of these photos of the failing stream banks themselves in upcoming slides. But these photos here are just some of these proposed techniques that we brought to the company. In the upper right, that's one that was sort of a core, more rock-based approach, which we ended up using on quite a bit of the stream bank that we designed, which was more of the hard armoring at the toe with boulders up to the ordinary high water mark, and then from there, a softening of the bank angle, soil covered and vegetated, and then tying into the existing bank above it. These images are nice because they show a little bit more of kind of what's going on in the innards of these features. A lot of the intent with some of these wood-based designs is that when they're all done, you don't see much of the insides of them, but there is a lot of structure and hardness to some of these wood-based designs that are shown at the bottom, which we also kind of needed to demonstrate to the county to get them familiar and somewhat comfortable with the idea of using wood at some of these sites as well. So at the lower left, we're showing sort of the approach of using root wads. In this case, showing the option to use root wads with stone over the top as sort of an extra ballast and extra sort of armament over the top. Again, those are in process, so that would be covered up with soil and vegetated over the top of that rock. And then the final two photos just show a tow wood complex where you're crisscrossing logs with root wads that would eventually, that soil would be lifted up and the root wads would be into the stream channel itself, and then showing sort of the next step of that process where those get covered up with brush. And then at the end stage of that would be covered up with soil and vegetated. So those are just some of the wood concepts that we brought to the county. And some of these habitat improvements do affect that water quality trading ratio. So they would get more credits by incorporating habitat features than just doing something like stone armament. Next slide. So now getting into some of the actual site designs, the largest site that we did was at Rotary Park along the Menominee River. That ended up being 500 feet of bank stabilization. And that site had 3 different sections, but it was all a similar concept of design. It was that upper right is sort of a typical condition of the pre-project site. Leif will be showing some construction photos of what it looked like sort of immediately post-construction. But that was pretty typical where you've got this higher bank that's eroding. A little bit hard to see in these photos just because of all the reed canary grass. But and then what we applied was this vegetated boulder toe, which I described earlier, where was rock at the base, and then we put in a floodplain bench, which was I think 5 to 10 feet at this site, and then tied it out at 3 to 1 above that. We did put in these things called rock wing deflectors, which I think I've got a little detail on following this slide. That was just a little sort of bump out at the base of these to provide a little bit more just variability along the base of the rock toe. Provides a little bit of scour at the base, a little bit of a pool, and a little bit of just habitat. And that was encouraged by the DNR as sort of a small feature, but something that would make this a little bit more of provide a little bit more habitat. So that was it was nice because it didn't induce any additional permitting, which was my big fear of doing anything that was going to invite any more Chapter 30 involvement. But it was a nice feature that got a little bit more habitat in the design and credit. We also put in some live staking at this site on the opposite banks. And one of the reasons for that was that the DNR was concerned with sort of increased velocity on the opposite banks adjacent to these armored sections. And then we also put native vegetative mat at this site. Most of the sites up above these stabilization areas, we were just doing sort of a standard soil and a native seed mix. But this one we actually went with the product where it's the rolled out native mat where they've started the seeds and you just install it in place. The other thing we did was the at this site, we did 2 sets of access steps where we sort of incorporated that into the stabilization for public access. Next slide. And this shows the rock deflector in a little bit more detail, which I think Leif has some images which do a little bit more justice to this than the CAD design, but I wouldn't say it's just a little pile of rocks, but it kind of is. Provides a little bit more, starts to look a little more natural than the designed riprap along the base toe. But it does break up the design a little bit and gives it a little bit more variability. And then, on the right just shows sort of a typical section of what we were putting in with the steps incorporated. Next slide. The next design was at Frontier Park, also along the Menominee River. On the left, you can see this is the downstream end of the site where we've got, this was actually the image that Leif showed where the bank recession from between years that he was comparing. So this was that downstream end where the trees falling in. There was a nice scour pool here that we really wanted to incorporate into the design. And just be aware that that was going to be a nice place where we could potentially have some wood and some fishing access. But that was a place where there's a failing bank, and we knew that as that tree was going to continue to cave into the river, that was going to induce more erosion and more failure of that bank. And this one also had an existing armored project at the downstream end that the village had put in, so we needed to incorporate that into the design as well. Next slide. So at this site was a little different. We did put in boulder toe and floodplain benching and bank shaping at the upstream end, similar to at Rotary Park. But we also, the site was wooded, so we reused the trees here and put in root wads at the lower end. So it's sort of at the upper half is more of a standard boulder toe with benching, and the lower half we incorporated the root wads. One of the things that did was that helped satisfy the Chapter 30 permit for integrated bank treatment, which does require the reuse of any cleared trees. And so I think this did work pretty well, and I think especially because there was that deeper pool, which I'll get into a little bit, but makes it a lot easier to incorporate wood when you've got a deep pool, and that can accommodate sort of the deeper dimensionality of a large root wad. So the other thing is we did put that fishing access steps at this site as well at the downstream end. Next slide. And then I think this site will be wooded eventually, so we did a native seeding for sort of the short term, but we also put in native shrubs and trees here for the long-term establishment. The third site was South Park Fields. This is along Underwood Creek. This one had some interesting stuff. On the lower left is the downstream end. This is I think there were 4 or 5 of these large concrete pipe sections that were, I think, put in as a revetment upstream of some bridge abutments that were left in place from when a former bridge had been there. And you can see one of them had tipped over, and there was some scour behind these. So those were removed as part of the project. But then upstream of there, you can see there's some pretty steep and pretty high failing banks that we needed to address. Next slide. So here we did a pretty similar approach in terms of putting in boulder toe with bank shaping. We did do a little bit more rock at this site. I know that just based on observation and experience, Leif had been concerned about some of the flows at this site, and just we did put rock a little bit higher here, but we also did put in a floodplain bench with the space we had available just to try to take some of the pressure off the channel. This was a pretty heavily wooded site with a lot of dead trees. We were able to find space to reuse 4 of the trees that we salvaged. We put those in as submerged logs, so that's a little bit different than the root wads in that they're instead of having the root wad into the stream channel, the log itself is into the channel, and the root wad is buried in the bank. And then we also did put trees and shrubs in on this site. So the north-facing site and really shaded. So we wanted to make sure that it was likely to return to being wooded over time. So we wanted to make sure that we put in tried to get that revegetated with better trees and shrubs that were likely to regrow there on their own. And this is just a detail of that submerged log structure. Which I think went in pretty well. Those were, I think, a challenge at this site because it was so shallow, but I think they were able to excavate those in. Last site here is at Pomona Road. This was further upstream on Underwood Creek than the last site. And these were sort of the typical conditions that we were looking to address on the left there. This was a higher bank at sort of the middle of the site. And then on the right is a section of the bank that was almost down at the very downstream end of the project area. And I think that was one that we ended up having to, not sure exactly how they did it, but I think they ended up having to sort of reach across with their excavator to try to put some rock there because it was technically kind of across the stream from where we were able to get access to. Next one. And here we again did a few sections of boulder toe with a little bit of benching in the upper section where we could, and then quite a bit of grading back in that middle section there. We put in some really small rock deflectors. Again, that probably saw that upper channel was maybe 5 feet wide at the most. So I think some of those were very minimal. The lower section was a little bit wider. And then I think on the lower end, we didn't have any space for any floodplain benches. So it was really just a small amount of rock with some softening of the slope upstream that since we weren't really able to have much space to work with the property boundary. And then I think at the downstream end, they were able to put some rock to stabilize that outer failing slope on the meander bend, despite the fact that they couldn't really get across the stream to work there, just with the access and the wetland disturbance. And then there were 2 areas of shrub planting here. Again, we couldn't get across the wetland to get equipment, and it wasn't really worth it to try to get across there, but they did want to try some vegetative restoration. So we put some shrub plantings over there. Next. Just a few closing thoughts on this before we get to some more illustrative photos that Leif will present on the construction. It was really nice to have the DNR flexibility in working through both the permitting and the ideas for how to incorporate habitat and working with the water quality crediting. Just thinking about how to reuse wood and kind of how to work with some of the requirements for the permit for the tree replacement and the habitat credits. So that was helpful. And then the other thing is just with some of this, like the reusing large wood and incorporating that, I found that as designing those, it sounds really nice until you kind of get to the cross section, and especially with urban channels where you might be dealing with water depths that during base flow are 4 or 5 inches deep, and they might be that way for most of the channel. You get these 2 or 3 foot high root wads, and you start looking at the cross section, and it's kind of challenging. So I think working through that issue can be somewhat difficult. The site where we put root wads did have that deep pool, which helped, but you need to be selective about where you can really feasibly put wood and incorporate that. So I think getting as good of survey and as dense of survey really does help that process. So yeah, I think that's all on the design, and I think Leif, you can go through the construction portion.
Okay. Well, the first step was we had a May 1st deadline to do the tree removal because in the wetlands, you have to respect the northern long-eared bat roosting deadline, which was May 1st. So we had the trees that were going to be salvaged, topped. The trees themselves were not all taken down. Some of them had the stumps left in place to be salvaged later, but by topping them, they were no longer habitat. That material was then stockpiled on the site for reuse later. And then on the site where in Menominee Falls, where we were doing opposite bank live staking, that also had a deadline where we wanted to get out there before the weather got hot and dry to get the live stakes in so they'd have a chance to get through that season. So we went out there and did 400 stakes of red osier dogwood and 400 stakes of willow. And then when the in-stream work started, the main method of sediment control was using turbidity barriers. And it worked pretty well on the streams where the flow was relatively slow and they weren't as flashy. However, the stream on the right was a section where there was a lot of gradient and the water was moving fast. And in that case, no matter how many sandbags we used on the toe of the turbidity barriers, it leaked sediment. But the one redeeming feature was that our contractor worked really fast, so they were in and out of there in literally a matter of hours. In the upper right in this picture, that's that same section of bank hours after that previous picture was taken. So they got in, they scooped out the soil that they needed to put in the bedding and the stone, and once the stone was in, the sediment loss was reduced to little or nothing. Our contractor was able to do 75 to 100 feet of bank per day, which I was just amazed at. But they got in and they got out really quickly. So here's a couple pictures illustrating how the boulder toe installation happened. And then for the root wads, in the upper left picture, you can see what their process was generally to scoop out about roughly 15 feet of the bank. And because the root wads stick about 6 feet plus into the bank, they had to excavate that roughly that much. And then in the center picture, they've got the footer log ready to be placed. And then the root wads, as in Nick's previous pictures, were placed on top of the footer, and then the spoils from the next 15 feet or so of bank were used to fill in around those logs, and then the stone went on top of those. So in the top left, the excavator's in the process of finishing up the stone and then starting to work on the steps that were put in. Another reason for putting in the steps, or the two of the reasons that we put in the steps were one, just as an attractive feature to make the whole project more appealing to our municipal partners, but also if there's steps there, that's kind of a sign to the public saying, hey, if you want access to the river, go this way instead of walking across our very expensive and sensitive native plants. So Nick showed some examples of the planting plan. So here's how it looked once it was implemented. So we had a mix. These are all native plants, which we needed to put in to replace the plants and trees that we were taking out. One thing we found was that you got to get some protection on those small trees as quickly as possible, because otherwise the deer get after them. And Nick showed the plan for the wing deflectors. In the left picture, you can see what one looks like when it's installed. And basically, they're heavy riprap that extends about 3 feet or so in a triangular shape into the stream. And he also showed a picture and talked a little bit about the downstream section of one bank erosion area where we had to reach across the stream to install it. So in the top picture, the center picture, it's showing what it looked like after the boulders went in. And in the bottom right, it shows the same picture after a major flood event. And I was just amazed at how well they held up. So on August 10th, this part of the county got roughly 12 inches of rain in less than 24 hours, which led to massive flooding. The top left picture is Frontier Park. And right at that point, this is about maybe 3, 4 days after the rain event. The water is still elevated about 2.5 feet above the base flow conditions. And the tree that got knocked over there, it had debris 7 feet up in the tree to show how high the water level got. So in that picture, the water level has already dropped about 7 feet from its peak. But surprisingly, of all the hardscaping work that we had done, there was essentially zero damage. There were a couple boulders that had to be moved a little bit back into place, but basically the boulder toe, the root wads, everything held up just fine. Where we did have some losses was in the recently stabilized areas. We had in the middle picture is Rotary Park in Menominee Falls. That had been stabilized or matted and seeded 2 days before the flood happened. And we essentially lost all the topsoil mat and seed there. So that had to be replaced, but fortunately we had a little padding left in our budget, and the repair work was all done through a change order within a month after the flood event. The bottom right picture is our site in Brookfield, and that was the one where the velocity of the water was probably the highest because there wasn't a lot of room for the water to spread out. And in that case, we had some areas that even though the grass had started to germinate, still got ripped up, but it was a fairly limited damage and we were able to replace it. We did lose some shrubs there though, in the opposite bank, so those had to be replaced. So altogether, we did a little over 1,000 feet of stream bank stabilization. The construction part of the bid was roughly $500,000. I don't have an exact number for that because we had a couple other small projects that were mixed in. But that worked out to a little less than $500 linear foot. The design for the stream bank work was roughly $100,000. And the load reductions before the 50% trade ratio and the 50% sharing with our municipal partners came to, for over a 5-year period, roughly 62,000 pounds of TSS reduced at roughly $9.60 a pound, and a 5-year total phosphorus reduction of roughly 81 pounds, which worked out to a little over $7,000 a pound. So my takeaways were that stream bank stabilization is a viable water quality trading option for MS4s. It costs a lot less than basins. Just to build a single basin in that watershed would have cost more than this entire project probably did between property acquisition and grading and everything. And in order to get enough load reduction, if we had built basins, we would have had to build dozens of them. So that was just totally impractical. It certainly costs more than agricultural trading would, but and as I tried to show earlier, that just we looked at it and could not find any. You can get habitat credits through the use of root wads, wing deflectors, J hooks, and there's about 8 other means that the DNR lists in the trading guidance. And Nick talked a little bit about the permitting process. It was difficult, but it was manageable. I had thought that working in waterways and in wetlands, we were going to have a lot more difficulty, but we were able to get through it in a reasonably expeditious fashion. It really made a big difference to have a good, experienced contractor. I can't say enough about the contractor that we worked with. They were just fabulous. And it turned out that working in stream was just the most effective way to reduce construction sediment loss and also the vulnerability to flood events. We used turbidity barriers and they had some effect, but they have their limitations. So with that, I'll see if there's any audience questions here. Let's see if I can get it back up. Let's try to see if I can stop sharing. Okay. So not seeing any audience questions. So unless somebody has something, Nick, I really appreciate your taking the time to present and all the great work you did on the project. It probably wouldn't have happened without you. So really appreciative. So that is pretty much it for today. We'll pick up again tomorrow morning at 8 o'clock. And once again, after the workshop is done, you'll get an evaluation survey, which you'll need to complete in order to get PDHs if you want them. And I think that's pretty much it. So I will adjourn for the morning. So thank you all for coming. I'll hope to see most of you tomorrow morning.